Hello, friends. The esteemed speakers and all the participants. I think we shall now begin our second session of invited talk for today. And in this session, Dr. Lorinthara Pachuao uh, from the Department of Physics, Pachu University College, will chair the session. So please take it over, Dr. Lorinthara.
Okay. What about my video? Hello? Can you hear me? Hello? Hello? Can you hear me? Anyone can hear me?
Yes, you are audible, Rinthara. You are audible. Please continue.
Hello? Okay. Today, in this session, we're going to get a lecture from Professor Mohan L. Verma. I think I should give some introduction for Professor Mohan Verma. Mohan L. Verma, okay. Professor Mohan, he is currently professor in Department of Applied Physics, Sri Sankacharya Technical Campus, Junwani, Bhilai. He is pardon me, my net is a little bit slow. Okay. He completed PhD in 2000, in the year 2000, in solid state ionic physics from RSSU Raipur. Afterward, he headed many research projects. He is the awardee of project fellowship by MPCOST, MPCOST. Award of research, another research fellowship by Ravi Shankar Shukla University, Raipur. And also Young Scientist Award by MPCOST Bhopal in the conference 1998 while he was pursuing PhD, and he has teaching experience of 19 years. And he is also very much interested in research modeling. Now, he published roughly more than 65 research papers in national and international journals. And as I said, he's currently heading the physics department in the institution. Now, if you're ready, Professor Mohan,
Yes, I'm ready.
Okay, the screen is yours.
Okay, thank you. Slide is visible.
So for some reason, only your cursor is visible and the white background.
Let me restart first. My voice is clear.
Sir, you are clearly audible, but again, probably I think the same case as was in the case of Professor Bansil. We are not able to see the PowerPoint.
What I should do? I should restart this.
Restart your PPT, sir. Let's see
if
it
yes.
works.
Okay. Is it?
Still not working, sir. I don't know if it's okay. I text you in your WhatsApp. If you can send me your PPT, I can share and control your PPT. If you cannot, if there's some issue at your end, I mean.
Okay, just I am sharing my PPT there.
Yeah, in your WhatsApp, I just text you, sir. It's completely blank. Dear participants, please bear with us for a few minutes. We will set up this thing very soon. For some reason, it's blank. Just your cursor. Yeah, I got it. I got it, sir, your PPT. Let me download it and share. Suddenly, my internet is slow. What? It's not downloading immediately. Okay, it's coming. Yep. It's opening. So let me take over the screen sharing so that you can share your thing.
Okay, so you will control.
Yes, sir. You just say next, and then I will.
Okay, so I have to say next. Okay. So control is now on your hand. Okay, thank you, the organizer, for giving me the invitation for this talk and to be the part of this international conference. And especially thank to Dr. Divya. Next. I would also like to thank my guide, Professor Rakesh Chandra Agrawal and Professor V. Pandey, and also my friend, Dr. Rodrigo, for their direct, indirect help and encouragement as well as blessing. Next. So I would like to thank my students. Actually, I involved in different research methodology, mathematical modeling, experimental as well as theoretical. So I have 80 students completed PhD. And next, these are my students working in the density functional based theory, and 3 are still working in different interdisciplinary subjects. I belong to this institution, Sri Sankaracharya Technical Campus, which is a NEC A-grade institution, and this is in Bhilai, Chhattisgarh, which is famous for Bhilai steel plant. Next. And this Bhilai, this is part of my beautiful Chhattisgarh, and Chhattisgarh is famous for its greenery. This is a glimpse of the front view of my institution. Next. This is my lab, the computational research laboratory, as well as my experimental lab, and the students are actively involved in theoretical work now. Experimentally is just a little bit less. And the motto of my work is, actually each and every research tool is individually incomplete. And this cartoon picture shows that the things individually that, please, the experimental research, mathematical modeling, and computational research will like be this cartoon, and individually the result may not be reliable. So we have to work as a team. Next. The outline of my talk. I have divided this talk in two parts. One is related to that experimental part, that introduction of that nanoparticle, and the second part that is related to DFT, and especially the application of DFT to study that magnetic properties of materials, as well as
welcome to track 2 of conservatory talks. So in the afternoon session from 2 p.m. to 3 p.m. we'll have conservatory talks.
Some sound is there.
All the participants should be ready with their presentations. And
okay. So please keep this in presentation mode. Okay, so the second part is related to density functional theory, which is, and especially the application of density functional theory to study magnetic properties of nanoparticles. Next. So this magnetic nanoparticles, actually the combination of two words, that magnetic and the nanoparticles, and from our graduation level, we are aware of these two terms, that magnetic and that nanoparticles. So the nanoparticles are especially that small particles, the size range between 1 to 100 nanometers, and especially that dimension is taken as 0, and undetectable by the human eyes. Nanoparticles can exhibit significantly different physical effect in chemical properties in different dimensions. And the second term, that magnetism, this is a force that can attract or repel magnetic objects, and we are familiar with these terms. Magnetic field that permits different medium mediates between force. And the magnetism, this is a property of certain materials. This is by default in certain materials, that is known as magnetic materials, or that materials can be converted into magnet or magnetized material by using different external sources. And then the magnetic nanoparticles, the combination of these two. It is a type of nanoparticles that can easily be cracked, manipulated, and targeted using the external magnetic field. And these properties of magnetic nanoparticles, this actually depends on experimentally the synthesis method and the shape of nanoparticles. Next. And the reason of this magnetism, we know that from our graduation level, it is talk about the magnetism of that materials. Like an electric current, magnetism is catched by electrons. So that the magnetic property, this is because of that the properties of electrons. And especially in our graduation level, we are also aware that the spin of electron is prominent over the orbital motion of that electron. So when these spins are balanced, the net force is 0. And if that it is imbalanced, then we have some unpaired electrons, and we will get that magnetic moment, and that the magnetic property will occur. And the electric current, this induced that magnetic field, and that magnetic field can induce that electric current, and that electric current passes through wire. It creates a circular magnetic field around the wire, similarly bringing a magnetic field near a good conductor of electricity. Electric current start following in this conductor. So this relationship between electricity and magnetism can result in many devices and its applications. So one thing here I just would like to emphasize is that spin, in theoretically also, that spin is prominent over that orbital motion, and this is responsible for magnetic properties of material. Next. So the classification of material, this is based on the size and as well as that orientation of dipoles, and on the basis of that orientation of dipoles and the size of dipoles, magnetic materials are classified into, the properties are classified into diamagnetic, paramagnetic, ferromagnetic, ferrimagnetic, as well as antiferromagnetic. So these are the fundamental things, and I think each and every students of PG levels are aware of this. Next. These are some magnetic materials in examples. The paramagnetic materials are that these are listed out, and I am not going to read it out because numbers are much more, and I have to complete that lecture within that given span of time. And now the properties of magnetic nanoparticles. This is biocompatible and relatively low toxicity in the human body, and this is less sensitivity to oxidation, more stability in magnetic response, easy of synthesis process and surface treatment. The dispersed ultra-fine magnetic properties should be stabilized in aqueous or other organic fluids. Possibility of transfer to supermagnetic form by the particle size decreasing. These are the ferromagnetic nanoparticles having single domain structure and the super paramagnetic behavior. Have a long Boole circular time, thus providing greater time of specific localization and the colloid stability in the biological environment, especially in the vivo media. And because of all these properties, the magnetic nanoparticles are mostly being used in biomedical fields. So next. Now the types of magnetic nanoparticles, mostly these are classified in different parts. One is the ferrites. The iron oxides or ferrites are the most explode nanoparticles, and these ferrites belongs to nanoconducting class of ferromagnetic materials and derived from metal oxides as Fe2O3 or magnetite Fe3O4. This is that simple primitive cell structure of this Fe3O4. Ferrites have three different structure symmetry: garnet, hexagonal, and cubic spinel ferrites, which are determined by the size and charge of the metal ions. They can exceed super paramagnetic below 128 nanometer. Here, I would like to mention that the behavior of magnetic nanoparticle, this is controlled by the size of that particle with a different temperature. Next. The ferrites with a sail, the surface of ferrite nanoparticles is in general inert. So to activate it, its reactivity, it can be improved by coating some other compounds on it. These have several advantages over advantages, including high chemical stability, narrow size distribution, and the magnetic moment that can be tuned with nuclear cluster size. So by just making a sail, it's a magnetic moment, it is manipulated on these ferrite materials. The studies on spinal ferrites have increased rapidly as they provide a better understanding and controlled super paramagnetism properties. And some compounds like that SiO2 and TiO2, this can be coated on spinal ferrites to obtain even more properties. Good. Next. Core cell inorganic compound nanocomposites. So depending on different applications, some hybrid nanoparticles can be created by combining two materials. And one materials may be pure nanoparticles, and there may be that core cell, just a cell, or both may be in magnetic and nature. So biomagnetic core cell systems such as FEPT, Fe3O4 or FEPT-CO Fe2O4, and here this both core and cell, these are strongly magnetic and they have a good application. Next. Now the dilute metal semiconductors. So this process characteristics of both semiconductor as well as magnetic properties. So these are the semiconductor but having magnetic properties. In this DMS, a fraction of the cation in the lattice are substituted by magnetic ions, and an atomic spin of this magnetic ions interact with the carriers in the lattice to bring paramagnetic orders in the materials. Especially in DFT based studies, what we are observing is where if we have some oxide, metal oxide or oxide of materials, and when we dope that transition metals or rare earth metals, then these doping induced magnetic field, and these are actually that dilute metal semiconductors mostly. Next. Now, the possibility is the polymeric magnetic, and we know that polymers have several advantages over general crystalline and non-crystalline materials because its size is flexible. So the polymer magnet or plastic magnet is a nanometallic made from these organic polymers. And these magnetic polymers can be defined in the substances composed of inorganic magnetic components in form of fibers, particles, or nanosite embedded in organic polymers or vice versa. The polymers can play a role such that this can be used as a template to control size and shape, as a coating protein from environment. So just I should conclude that this is a very good materials because it's flexible in nature. Next. Now, different experimental methods are there to prepare these magnetic nanoparticles. So, co-precipitation methods, microemulsion method, all these depends on the types of materials, conducting polymer synthesis method, and polymerization in presence of magnetic nanoparticles, polymerization synthesis method. So they have several advantages as well as some limitations. So I'm not going to the details. Next. Now, different applications. They have nanoparticles have industrial applications, catalytic chemical applications, environmental applications, organic pollutants, inorganic pollutants, and these are very important materials, very useful materials, and they have abundant numbers of applications. Next. Here, three main applications. These are biomedical applications, and one of the most prominent application, that is the cancer therapy. In magnetic fluid hyperthermia, nanoparticles of different types like iron oxide and magnetite type materials, and these are injected in a tumor and then subjected and just applied high frequency magnetic field, and because of that temperature increases and up to that 40 to 46 degrees centigrade, and these can kill the cancer cells. So this is one of the good method to treat as well as to detect cancer. Information storage, this is also useful in storage, and the genetic engineering, this magnetic nanoparticles are useful in this application also. Next. Now, the next part of my talk, that is in the computational field, the DFT based study, and this is that scale and the time scale. And we started from that quantum mechanical DFT to that continuum models, and that persons working in the theoretical fields, computational field, that follow this, and depending on that computational facility available as well as the types of materials. Next. Now, DFT, this is also known as ab initio or first principle, and one can say the synonyms of DFT is these two. And this is that time scale of the development of DFT starting from 1900 to 1998, where that Nobel Prize was won by Volker Kuhn. And next. This is, one can say this first principle study is actually can be used as a bridge between theory and experiment. It's, I have mentioned in my motto part that we have to work together. So we need the help of experimentalist to just verify our theoretical models. So this first principle based study, this is the gap between, they fill the gap between theory and experiment. Next. DFT, this is a description of interacting electron in ground state, including exchange and correlation, the basic variables in the density rather than wave function. So in the Schrodinger equation, this is the solution of Schrodinger equation, but in Schrodinger equation, wave function is used, but in density functional theory, in place of a wave function, density is used. The theory is simple and implementable, efficient compared to other methods, and this is computationally cost effective. So this is more useful than other computational method. Next. This is the method adopted by that DFT. We started from that wave function and calculate this is the flow chart, computed that carrier density and R as a function of position, and then this Vxc, and that once iteration is followed up to the system is optimized, and the final result is found in terms of calculated energy and force. Next. So these are the application. We can get self-consistent total energy by using at ground state, by using DFT in the different shape and size of particles as well as materials. A structural, optimized structure, elastic modulus, electron phonon band structure for many body system, phonon frequencies, full phonon dispersion, electron phonon interaction, even AB initio molecular dynamic simulation, optical properties, transport properties, surface analysis. All these are the properties which can be analyzed by using this DFT. So this is one of the from my lab where we have studied the magnetic properties of this TIN based materials. This is planar structure. So in density functional theory, or in the tool we are using here, what we perform is we just study spin polarized type system and get projected density of state and density of state. So one plot here that's showing in that projected density of states in up spin and down spin. If there is a difference between up spin and down spin plot, then the gap is shown, and that calculation it is automatically given in output file of that tool we are using in terms of that Bohr magneton. Next. So now the buckyball structure. So this is the first nanoparticle, one can say, and this is called fluorines also. And one of the this is the first nanoparticle discovered from 1985 to 1990. We have this C60 and C70. These were discovered and known as that cage type structure. And then some further carbon cage were obtained, that C36, the C35. And that experimental evidence were also obtained in support of this. And this actually opens one era, one field of research by replacing that carbon atom with a different atom and form cage-like structures and study different properties. Next. So we have started that studies in the Giordano buckyball, and one of my students designed this Giordano buckyball having 24 atoms using that Avogadro software, and that interaction between graphene and this buckyball were studies and reported in this paper. Next. And what we observed when we, in general, this Giordano that buckyball type of structure, this is inert as far as the magnetic property is concerned. Means there is no magnetic moment reported by that Giordano buckyball as well as its hexagonal structure. But when we dope some materials, just like aluminum here showing, it induced some magnetic properties in that material, and that we have studied this doping in the center as well as on the surface of this buckyball structure. And since this is in the publication state, so the details are not given here, but just I am showing one example here. This Giordano buckyball, which is initially non-magnetic in behavior, when we dope some materials like silver, copper, and gallium, aluminum type materials, then it is showing magnetic properties. Okay, that magnetic moment is not much more, but the magnetic properties is induced in the material. Next. So by using that Giordano as a template, we have developed some more buckyball type structure that starting from this chromium oxide, MnO, and that FeO as well as this nickel oxide. So these are different buckyball structure designed in my lab. And here in this figure, two parts of that buckyball is showing, and that spin up and spin down density of state, dust clot is also with that, and the magnetic moment calculated, this was mentioned in the same plot. So here in chromium oxide, that magnetic moment was 40 Bohr magneton, but this magnesium oxide, it's up to 60 Bohr magneton, and this 48 Bohr magneton, and that is in 24 about Bohr magneton. These are the magnetic moment. This is much more high with compared to its different structure. For example, in FeO hexagonal structure, it's about 8 Bohr magneton. But when we are just forming one buckyball type structure, it's Bohr magneton reported up to that 48. So this is much high. And why it is so that we are studying that result, and it's already in the form of paper, and very soon this will be communicated with some more relevant information. Next. So we are using SISTA tool to study all these materials, and this is a very good tool for beginners. If anyone want to start working in the DFT, then SISTA can be used. Next. This is a very good method and computationally effective. So I'm not reading this text because it's a good documentation. It has good documentation. Next. So if anyone want to start this, so simply for beginners level, for learning stage, one can start from IT core with 4 GB and Linux operating system, and make Google as a friend, and the internet facility if you have, then you can learn this SISTA tool. Next. So, okay, this is very good documented tool. Next. This is the input file I have used for the study of this magnetic properties, and this is related to this FeO buckyball. And here, that method I have adopted, that is spin polarized here. The last part of this slide where spin polarized true is mentioned, and other terms are similar to other FDF file. Only additional term to study magnetic properties if that spin polarized is true. This is a rough estimation, and here just I have used that functional is GGA in PBA mode, and number of CG steps we have taken 500, and basis set I have taken DZP. Next. This is the output file. In the output file, in the end of this, in the last part of this left hand side term, that spin moment, it is mentioned at 48.00020 is the magnetic moment measured after optimization of the system. And by using a simple DAS to data conversion tool, we have this spin up and spin down and by plotting this, one can get that result I have shown in the last diagram. Next. So for the beginner, I have a very good YouTube channel to learn SISTA, and many about 853 students and others are taking help from this. And if anyone interested to start learning SISTA, you can start from here. Next. So further work, actually, just I have mentioned, this is the rough estimation because I am just using spin up and spin down type density of state, and getting there is some magnetic properties is introduced in the material, but that what type of magnetic properties are there and what is the mechanism behind that, these are needing some detailed study. So the detailed study of magnetic properties, this can be refined by using DFT plus U as well as spin orbital coupling. This is a very good method for that to study the magnetic properties, and tuning the magnetic properties using different dopants. As I have mentioned in buckyball, if there is no magnetic properties and when we are using proper dopant, then one can get magnetic properties induced there. And some experimental support to verify our result. This is also very important. So I think I should stop here, and I've taken some more time. Thanking you all.
Dr. Lorintara Pachuo, our chairperson here.
Hello.
Is still online? Yeah.
Yes. Thank you so much for Professor Mohan.
Yes.
We thank you so much. It seems
welcome.
You were a little bit too hurry there is still plenty of time, but it seems you're in a bit hurry.
I was thinking I have to complete for 2 and 30 because for the next 2:35 35 minutes was allotted, so it's a 2:35 at least.
Okay, anyway, we thank you so much. I hope we can still have some future cooperation with our department.
Yeah, we can.
Okay, now I think we can go straight through the comments and any kind of questions. Hello? Is there any comments or any questions regarding the lecture?
Hello?
Yes.
Hello? Can you hear me?
Yeah.
We can.
Hello, sir. It's Dr. Rai.
Yes, Dr. Dibya, thank you.
Thanks to you too, sir, for your time and very insightful talk. Sir, I have a question. Like generally, this MnO2, FeO2, I think they are in their bulk state. They are a cubic structure, right?
Yeah, they have 3 to 4 type of structures. By using that material project, we are getting many structure. Mostly 3 to 4 type of structures are there, and some structures are showing magnetic properties.
And my question is like the result which you have shown is about the when you are like reducing the size, right?
Yes,
it becomes spherical shaped nanoparticles.
Not reducing the size, actually. That generally nowadays we are creating this buckyball type structure by using that tool. One tool is there, that nanotube modeler. There's a tool to create this buckyball type structure, and obviously that size is being reduced after creating by using any tool, and its property is drastically changed. From crystal to regular crystalline structure to this buckyball structures.
Sir, may I know which tool you have used?
For this structure, I have to reduce. For this structure,
sir, suppose I have any crystal structure having a FCC, FCC lattice. Then if I have to reduce it reduce to its nano size, sir. So will it be in a still like cubic type of nanocrystal, or it will transform to a spherical one?
That transformation is not possible to that crystal to this buckyball. You have to create this buckyball structure using a separate tools by your own. You can use that fluent type structure of carbon and just replace manually that atoms. And you have to design. So we have performed like that. So we have taken 24 atoms of ZNO initially, and Avogadro tools we have used earlier, and get a good result, optimized result of ZNO. And now I just studied this material by taking the template of that ZNO buckyball, by replacing Zn with this Fe, by replacing Zn with this chromium or cobalt, and optimize the structure. So after optimization, the shape is still in spherical, and in the last that nickel oxide, I think the shape is slightly distorted. So during optimization, you have to take careful.
Any difference in their stability between the cubic crystal, nanocrystal, and the
sometimes this buckyball structure is more stable than its some other structures. So it depends on the material. One cannot say that all the buckyball structures are stable, but we have this needs some more study. Sometimes that stability, it is manipulated by using different dopants too. So when we are using dopants, its stability is increasing, and sometimes what we are observed that it is stable mechanically, it is stable, but thermodynamically it is not stable like that also. So
So these all nanoparticles are like made from Avogadro.
Yeah,
software,
one
right?
this just by Avogadro, and that nanotube modeler can be also used. There is some good tool for
Thank you, sir.
sensor structure design.
Thank you, sir. Thank you.
Okay.
Sir, this is Dr. Zola, a colleague of Dr. Divya Rai. So I
Yes,
think
I
I have
know.
communicated with you
Yes, we have.
over
Yes, we have.
WhatsApp also.
Yes,
Yeah.
yes, we have.
Me and Divya, we have learned a lot from Professor Verma, particularly in this siesta, because me particularly, I did my doctoral thesis work in experimental lab in IIT Guwahati. So I
Yeah.
learned few things from Dr. Divya, and then uh, I learned from you, and your YouTube channels are actually quite very helpful to me because I have
Yeah.
downloaded most of the YouTube videos you have uploaded in your channel, and I've gone through them. So they are quite elaborate and quite helpful to the beginners like us.
Yeah,
So
yeah, it's
regarding
designed for
your
beginners. Yeah.
yes, regarding your talk, like see as I said, I'm also like with a experimental background during my PhD work, and I wonder at what condition, at under what condition, under what parameter, it would be feasible to fabricate this kind of buckyball structure.
It's a tricky.
A little
I
bit a
just
new
mentioned
concept.
it's a really tricky. It's a really tricky, and
Yeah.
many times it take much time. Manually, if you use Avogadro, and if you have already cached, if somewhere you are getting that C24, C30, and just by replacing carbon and oxygen and optimize, then sometimes it takes 2 to 3 hours. Or just ask me for that this template I can provide you, and you can design using this material, this JNO also. But this is for the 24 atoms, because JNO buckyball, it is stable in this structure. If you increase the number of atoms, it's a shape, that is spherical shape is distorted. So, and this is reported first, it is reported by Ravi Pandey group, and the interaction between the JNO buckyball with DNA molecules, it is reported by that, and we have taken, we have observed that structure from one of this paper, and then we tried this ourselves and get a good result.
Yeah, thank you, sir. Yeah, thank you for sharing your works with us that are quite enlightening, sir. Thank you.
Okay, thank you.
Is there anyone else?
Good afternoon, Professor. I'm Bhanu Chetri, sir.
Yes, Mr.
It
Bhanu.
was a beautiful talk, sir, and it was a privilege to have known you and your colleague personally and walked under you for some time through my supervisor, Dr.
I remember
Divya, right?
Okay.
Sir, I have a small query on those magnetic buckyballs, no, sir. Those you have shown. Like, how did you test the stability of those structures, sir?
Generally, we in our papers we have reported that we tested this stability by using binding energy or cohesive energy, and that enthalpy, and we have some formula depending on the energy of individual atoms and the energy of that the complete shape, and for that dynamical stability we use phonon, but for phonon structures we need that plex for the bands. So we have not tested dynamical stability of this, but the thermodynamical as well as structural stability we are getting by using cohesive energy in that. I'm not giving detail here because that is in publication mode.
Oh, okay, sir.
Okay.
Okay, thank you, sir.
Anyone else?
Can you hear me?
Yeah.
If we are doing DFT calculation for ferrites, like spinal ferrites.
Yes.
So per unit cell, there are around 56 atoms or ions 56. In a unit cell. Yes.
Yeah.
So how much like computational power like we need in order to perform such for large like per unit cell system calculations, DFT calculations?
So actually, this sister, this has a very good power. By just we start from 1 unit cell of that, and automatically it starts running in form of bulk. And generally, whenever I use that computational tool, like in this sister tool, I take one small primitive cell, and by studying that study, by studying the details of that materials, I then use supercells if needed. Okay, so I have some computer systems with 6 nodes, and sometimes if a number of atoms are 20, 25 atoms, then within 2 or 3 hours with CG steps 500, about 300, 400 CG steps, the optimization is completed. After optimization is completed, properties can be studied. So optimization is a main thing, but molecular dynamic simulation, it takes much more time. So within 2 to 3 hours in our system, having 6 core, if my laptop with 4 cores, this is i7, so for 2 cores, it takes about 6 to 7 hours. So this is okay. I think with compared to other tools.
Okay. Thank you, sir.
Excuse me, I have one quick question.
Yes.
Sir, in Siesta, can we implement hybrid functionals?
Not so far. Hybrid functional means just we can combine only GG and LDA so far. And if we want to change that GG and DFT, then we use DFT plus U numbered correction for the study. But hybridization is not possible so far. Result some we're trying, but results are rough, not getting good results. So GGA is enough for the preliminary studies. For detailed study, you have to use other tools related given in utils.
Thank you, sir.
Okay. Anyone else?
Oh, yes. Although we may still have many questions, but due to time constraint, it seems we have to go to our next talk. Thank you so much for Professor Mohan Verma, sir.
Okay, thank you.
If Dr. Kulinder is there, what about Dr. Kulinder?
Yes, sir, I'm here only.
Okay. If you are ready,
yes,
I think you can proceed for your lecture.
okay.
Hello.
Yes,
just before.
Just make me a co-host, then I will share my screen.
Madam, I have just made you a co-host. You are enabled now.
Right. Let me just talk about Dr. Kulinder. She is currently assistant professor in Department of Applied Sciences, Punjab Engineering College, Chandigarh. She completed both MSc and PhD from Punjab University, Chandigarh, and postdoc from Department of Physics, IIT Madras. And she is having around 38 publications in reputed international journals, and she is currently reviewer for many Scopus Index journals, and she got Outstanding Reviewer Contribution Award from Journal of Physics, Chemistry of Solids, Journal of Alloys, and Journal of Alloys and Compounds. And currently she is life member of Indian Association of Physics Teachers and Chandigarh Vigyan Prasad. And she was selected as finalist rising star in computational material science. She got Best Presentation Award in International Conferences and Travel Grant from the Abdas Salam International Center for Theoretical Physics, ICTP, Italy, and Ras Al Khaimah Center for Advanced Material Sciences. All right. Now, if Dr. Kulinder is ready, we invite her to give her presentation.
Okay, sir, is my screen visible to everyone?
Yes, it's visible, madam. Please go ahead.
Okay, so good afternoon to all the participants and the organizer of this event. So first, I would like to say thank you, sir, for introducing me. So I would also like to thank the host of this great event and also inviting me on this international conference on material science and applied physics, and also for giving me the opportunity to share my work on this big platform. So today I will give a talk. On computational prediction of 2D and 3D thermoelectric materials and their applications. So I am going to discuss about the different energy sources, and the main focus is a thermoelectricity. So in my talk, first I will discuss some important points why the thermoelectricity is important and how can we generate thermoelectricity. So which material we can use as a thermoelectric material. So what are the applications of thermoelectric materials? So which factors are playing an important role to enhance the efficiency of thermoelectric devices? At last, I will discuss how can we calculate the thermoelectric coefficient of thermoelectric materials using the density functional theory. So as we know that the world are facing the difficulties regarding the energy sources in the scientific community, people are trying to find the solution to overcome the energy crisis. So the world is facing different difficulties like energy management. How can we manage the energy consumption, source of energy, and the pollution created by the different energy sources. So the main reason in the world population and demand of the long-range electrical and electronic-based devices, which is needed in the modern life. So in 2017, in this figure, you can see that in 2017 in India, most of the energy we are getting from the non-renewable energy sources. Like 56% we are getting from coal, and 29% we are getting from oil, and 6% we are getting from gas, and 4% from hydro, 1% from nuclear, and only 3% we are getting from the renewable energy sources. So energy crisis is the major issue. To overcome the energy crisis, there are different types of methods are available, like nuclear power plants, solar energy. In this figure, you can see that, like nuclear power plant, solar energy, geothermal energy, wave energy, biomass energy, and thermoelectricity. So here I will discuss one energy source is known as a thermoelectricity. So why this thermoelectricity is important? So there are some nasty problems in the world, like increasing pollution, increasing energy demand, and increasing icy heat. So we are getting the heat from the different ways. We are getting the heat from the different energy sources. So in there we can get the waste heat. So in all field of sciences, engineering and technology, waste heat is available in everywhere. So when the fossil fuels are burned, approximately 30 to 40% energy is utilized in the heat engine. So here I will take one example of a car. Roughly 25% of the gasoline is used to move and power the car. And where does the rest of the heat go? So it is lost as a unusable heat. But what we can do with the wasted heat? Can we recover it? So there are lots of questions comes in our mind. So there are different energy sources like the thermal power plant, nuclear power plant, and natural gas. Only the 34% energy in this diagram you can see that. Only 34% energy is used and rest of the 66% energy is lost as a waste heat. So what are the sources of the waste heat? So like we can get waste heat from the industries, factories, data centers, kitchens, stoves and gas burners, dryer, refrigerators and the computer. These all are the sources of the waste heat from where we can get a waste heat. So let's suppose if the wasted heat could be captured with the wasted heat, which we are getting from the different sources. If this waste heat should be captured and transformed into the useful work, so it would indeed enhance the fuel economy and decrease the dependence on the fossil fuels. Here, the physical phenomena of the thermoelectricity comes to our rescue. So it is one of the many ways waste heat may be captured and utilized. So what is thermoelectricity? So in this method, we can convert waste heat into the electricity. So there are some special features of the thermoelectric devices. So these devices are noise and pollution free, have long life cycle, maintenance free, do not contain any toxic element like chlorofluorocarbon, or these devices are lightweight and small in size and also not a location dependent. So keeping all these things in our mind, we can say that thermoelectricity is a key feature of the green energy generation technology. So carried out in a cheap, pollution-free and easy way. So thermoelectricity is served as an environment-friendly method to overcome the energy crisis. So here I will discuss a three effects. These are the thermoelectric devices are based on these three effects. First one is the feedback effect, and the second one is the Peltier, and third one is the Thomson effect. So in the feedback effect, the voltage is produced when two different metals or semiconductors are joined, and junction between these two are maintained at a different temperature. So this Peltier effect is a reverse effect of the feedback effect. And in Thomson effect, any current carrying conductor with a temperature difference between 2 points will either absorb or emit heat depending upon the material. So these thermoelectric devices are based on these three effects. So now we will understand the concept of the thermoelectric devices. So in this figure, you can see that where P is denoted as a P-type semiconductor, which is containing a positive charge carrier, means hole, and N is denoted as a N-type semiconductor containing a negative charge carrier, means electron. So when the current I, this is current I, when the current I is passed through the junction, the charge carriers, these charge carriers, hole and electron, move away from the junction and carry heat energy Q away. So the junction becomes cool. This effect is known as a Peltier effect. So you can see this effect in the B part. And in the opposite case, a temperature difference exists in the first case, this A, in figure A. So this is the opposite case. A temperature difference exists at the junction delta T. When the charge carriers move away from the junction, so the voltage the voltage D is produced. So this is known as a CVAC effect. So this one is a thermal in this figure, this right hand figure. This is a thermoelectric module. The thermoelectric module is based on all these phenomena. So it contains a thermoelectric module contains a number of semiconductor pellets, means thermocouples. So which have been doped and contain a one type of charge carriers, means P type or N type charge carriers. So these semiconductor pellets are connected in series. You can see in this figure. These are connected in series electrically and parallel thermally. So when the circuit is completed in the module, the heat is rejected from the one end. The heat is rejected from the one end and absorbed at the other end. So the output voltage of the thermoelectric power generator is proportional to the number of semiconductor pellets and the temperature difference between the cold side and the hot side. So we can say that the efficiency is depends upon the material, however it's P type or is N type. So what are the applications of thermoelectric materials where we can use thermoelectric materials? So the main applications of these materials are power generation and refrigeration. So in the case of power generation, we can use these materials in radioisotope thermal generators, and in large scale in power plants, and in small scale we can use in automobiles, or in the second case, in the case of refrigeration, we can use the thermoelectric materials in active cooling and the warming. In CPU and cooling and warming the seats of the luxury vehicle. So these are the main applications of thermoelectric material where we can use this material. So these are all about the importance and the applications of the thermoelectric material. So here we will discuss a one parameter which characterizes the efficiency of any thermoelectric devices, which is known as a coefficient of thermoelectric performance. The coefficient of thermoelectric performance depends upon the figure of merit. Figure of merit, which is known as a ZT of the material. If the value of ZT increases, the coefficient of performance is also increases. In this figure, we can see that when the value of ZT is increases, the coefficient of the performance is also increasing. So the coefficient of performance is directly dependent on the value of ZT. So ZT is a combination of S is a CVAC coefficient, and sigma, which one is the electrical conductivity, C is absolute temperature, and K is a total thermal conductivity. And the total thermal conductivity is a sum of the contribution of thermal conductivity due to the electron and due to the lattice or the phonon contribution. So in this figure, you can see that for the coefficient of performance in the case of refrigeration depends on the value of ZT. So as the value of ZT increases, the coefficient of performance is also increases. So now we will discuss which type of materials are suitable for thermoelectric materials. So there are three different types of materials available, like metals, insulators, and semiconductors. So first I will discuss the case of metal. In the case of metal, the free charge carriers are very high. So due to that, the electrical conductivity is very high in the case of metal because the charge carriers are very high. It is 10 raised to power 7. And the CVAC coefficient is very low. In this case, the CVAC coefficient is very low. So we know that the electrical conductivity is directly depends upon the carrier concentration, and the CVAC coefficient is inversely dependent upon the carrier concentration. That's why, due to the presence of large number of charge carriers in the metal, the electrical conductivity is very high and the CVAC coefficient is very low in the case of metal. So next, I will discuss the case of insulator. In this case, the band gap is very high, so the conduction of the charge carrier is less due to the large value of the band gap. That's why the electrical conductivity is low and the Seebeck coefficient is high. So the next type of material is semiconductor material. In the case of semiconductor material, the electrical conductivity is good and the Seebeck coefficient is also high. So the value of thermal conductivity is low in the case of semiconductor. So we can say that the semiconductor are most suitable thermoelectric materials. So for the efficient thermoelectric materials, the Seebeck coefficient and the electrical conductivity should be high and the total thermal conductivity should be low. That's why the value of our ZT is high, so the coefficient of performance will be high. If the value of ZT will be high, so the coefficient of performance also will be high. So now we will discuss the relation of thermoelectric coefficients such as Seebeck coefficient, electrical conductivity with the density of state. So everyone knows that the density of state given the number of allowed electrons and hole states per volume at the given energy. So even this figure shows the variation of density of state with energy in the different type of materials, such as the first one is bulk material and second is the quantum well and the quantum wire and quantum dot. Means 3D material, 2D material, 1D and 0-dimensional material. So now we will talk about the dimensionality of the materials or the thermoelectric coefficient depends upon the density of state, which is very important parameter. So all the thermoelectric coefficients are depending upon the density of state in 3D, 2D, 1D material. So if the density of state at the Fermi level is small, so the value of Seebeck coefficient will be large, and so the band should be a flat. And if the large density of state is available, so the value of Seebeck coefficient is low. So we know that the Seebeck coefficient and the electrical conductivity are inversely depend upon each other. So if the density of state at the Fermi is high, so the value of electrical conductivity should be high and the band should be steep or dispersive. So density of state, we can say that the density of state is playing this important role to enhance the thermoelectric coefficient. So our next target, how can we reduce the value of thermal conductivity to enhance the value of ZT? So in the bulk material, Polyne and phonon rattlers are the techniques which are used to reduce the value of thermal conductivity. So in the bulk material, first technique is Polyne. What Polyne is easier, this is very easiest way to reduce the lattice thermal conductivity without any reduction of electrical conductivity by substituting the different atoms in the crystal lattice size. So the doping atom should have a similar electronic structure and belong to a same column in the periodic table. So here I will take one example. Like the lattice thermal conductivity of the silicon is approximately 150 watts per meter per Kelvin for the single crystal of the silicon. And for the single crystal of the germanium is approximately 60 watts per meter per Kelvin. But when we dope germanium with silicon, the lattice thermal conductivity will equal to approximately 10 watts per meter per Kelvin and make this material to the efficient thermoelectric material. So we can say that with Polyne we can reduce the value of lattice thermal conductivity. So with the second technique is a phonon rattler. In this method, we can incorporate the different atoms in the case-like structures that can be treated as a scattering center and reduce the value of lattice thermal conductivity. So this is how can we reduce the thermal conductivity in the case of bulk material. So in the case of nanostructure materials, due to the quantum confinement effect, the phonon scattering increase because the surface and the interfaces are present. So the presence of the surface and the interfaces, the phonon have a large mean free path. So which can scattered the phonon more than which can scatter the phonon. So more the scattering, so the lattice thermal conductivity will decrease. So from our discussion, we come to know that the heavily doped semiconductor is a best thermoelectric material. So there are some conditions on the best thermoelectric materials like degenerate semiconductors, semi-metals with carrier concentrations 10 raised to power 18 to 10 raised to power 20, semiconductors with band gap approximately 10 kVt, materials containing heavy elements are considered as a good thermoelectric material. So now I will discuss some thermoelectric materials. First, I am going to discuss about the Husler compound. So there are three types of Husler compounds available. So first one is the half Husler, which is denoted as XYZ. So these are the Wyckoff positions of half Husler compound. So where X site is occupied by the transition element and alkali metals or the rare earth metals, and Y site is occupied by the transition metal, and Z site is occupied by the main group elements of group 13 to 16. So similar for full Husler compound, there is one in half Husler compound, there is one position is empty. So you can just put one another element in this empty space. So it will become a full Husler compound. And in quaternary Husler compound, when we replace some of the suitable elements, either X or Y, Z, in half or full Husler with the electropositive element having a suitable size, so it will become a quaternary Husler compound. So there are some emerging applications of Husler compound like half metallicity and the topological behavior used in spintronic devices, in spin devices. Half Husler has shown the exceptional optical properties which are believed to be very useful in optoelectronic devices applications. So quaternary Husler also shows some magnetic and thermoelectric properties. So these compounds having a good mechanical properties like Young's modulus, bulk modulus, Poisson ratio, and mechanical strength. So these compounds are promising thermoelectric material also. There are some property of the Husler compounds because these are non-toxic and environment friendly. They are dynamically stable and suitable electronic properties. So these all are the examples of some quaternary Husler compounds which are efficient for the thermoelectric materials. So the figure of merit of these materials are reaches to unity in many of the Husler compounds. So, but there are also some still quite possibilities to search the materials in the same class. Those can have the promising thermoelectric materials. So now I am going to discuss the stability and the thermoelectric property of some half Husler compounds PTXSN. Here X is ZR and SF. This work is published in Journal of Computational Material Science. So in this work, we have explored the structural, electronic, mechanical, dynamical, and the thermoelectric properties of some half Husler compounds. So the electronic properties are calculated with the quantum espresso code, which is based on the density functional theory. And thermoelectric properties are calculated with Boole-Scrap code, which is based on the semi-classical Boltzmann transport efficiency. And the lattice thermal conductivity is calculated with a Cheng-Vitti code. So in this work, we have calculated the structural parameter like lattice constant, bulk modulus, derivative of bulk modulus, effective mass, formation energy, cohesive energy of the material. So the negative value of formation energy indicates that these materials are experimentally possible. So this figure shows the phonon band structures of the material. So we found that there is no negative phonon frequency is available, so which indicates that both the materials are dynamically stable. So here you can see a visible separation that can be The visible separation that can be noticed between the optical and the acoustic phonon. And this one is a acoustic and upper one is a optical phonon. So the small phonon band gap or the maximum overlapping in the acoustic and optical phonon modes is a main advantage in reducing the phonon scattering, and it is useful to attain the low value of the lattice thermal conductivity. So the thermal conductivity is directly related to the acoustic phonon branch. So in this case, the value of the frequency for the acoustic phonon is approximately 160 in the case of ZF, and in the case of HF, this is equal to 106. So these compounds are dynamically stable. From this figure, we can say that these materials are dynamically stable. So this figure shows the band structures of both materials in this material. These materials are indirect band gap semiconductors with band gap 1.23 electron volts and 0.88 electron volts. So the balance band, this lower panel is a density, partial density and total density of space of these two materials. So the valence band and the conduction band edge are composed of the d orbitals of ZR and HF atoms. So the contributions of d orbitals of ZR and HFR are more populating around the Fermi level, as you can see in this figure. So there are some significant contribution of the d orbital of PT atom and p orbital of SN atom. So next, I will discuss some thermoelectric property of these materials. First, I will discuss the Seeger coefficient and the electrical conductivity of this material. So we have calculated the Seeger coefficient and the electrical conductivity of these materials at different temperature at 300, 500 and 700 Kelvin temperature. So at 300 temperature, the maximum value of the Seeger coefficient is 1600 at 300 Kelvin. So as the temperature increases, the Seeger coefficient decreases and attains 800 value at 700 Kelvin. So at 300 Kelvin, the maximum value is 1600. But when the temperature increases, the Seeger coefficient decreases, and at 700 Kelvin, we are getting the value is 800. So we can say that this is due to the enhancement of thermally excited charge carriers. So I have already discussed in our previous slide. So the CVAC is inversely depending upon the carrier concentration. So the electrical conductivity in the second panel. So the electrical conductivity of HF material is high as compared to the ZF material. So it decreases with increase in the temperature So electrical conductivity is directly dependent upon the carrier concentration and the mobility. Sigma equal to NE mu, where mu is a mobility. So in this case, the mobility is dominated by the lattice scattering. So mobility is inversely depending upon the temperature, which is part T 3/2. So that's why the electrical conductivity is decreasing with increase in a temperature. So next, we have also calculated the lattice thermal conductivity and the relaxation time. So with increase in the temperature, the thermal conductivity decreases. So the thermal conductivity has an inverse relation with the temperature, and at room temperature, the value of lattice thermal conductivity is 16 in the case of ZR and 10 in the case of HF. So relaxation time in second figure, B figure, the relaxation time is also decreases with increase in temperature due to the increased collision rate. So finally we have calculated the figure of merit for both materials, and the value of ZT is 0.57 in the case of HF and 0.24 in the case of ZF, at 700 Kelvin. So these compounds have a better performance in the P-type region. So there are some important features. So these materials are indirect bandgap semiconductors and they are dynamically stable. The maximum value of these materials are approximately 1600 at room temperature, and the electrical conductivity is 6.58 into 10 raised to power 5 in the case of HF and 4 into 10 raised to power 5 in the case of ZF. And the maximum value of ZT is 0.57 in the case of HF and 0.24 in the case of Z. So we can say that these materials having a better performance in the P-type region. So next we have also calculated the structure, electronic, mechanical and dynamical and thermoelectric properties of lithium-based quaternary fuel compounds. These are lithium-based quaternary fuel compounds. This work is published in the International Journal of Energy Research. So these materials are stable in FCC cubic structure with a space group of F43M. So these are the positions occupied by the different elements in this in quaternary fuel compounds. So these are the properties: lattice constant, bulk modulus, and band gap. We have calculated for these materials, and these optimized parameters of these materials like lattice constant, bulk modulus, and band gap. And these results are giving a good agreement with the previous reported results. So from the band structures, we can find that these materials are indirect band gap semiconductors with band gap 1.22 and 1.09 and 0.85. So in the band structure, the band degeneracy is some band degeneracies are there in the valence band. So band degeneracy playing an important role to enhance the power factor. So these are the density of states. From the density of states, we found that the valence band is composed mainly due to the d orbital of the quartz, and conduction band is mainly due to the d state of the titanium atom. So these are the phonon band structures, similar like a half-use cell compound. In this case, we have also not found any negative phonon vibrating mode. So this indicates that these materials are dynamically stable. So next we have also calculated the Seeber coefficient of these quaternary compounds. At 300 Kelvin, these in the case of lithium, titanium, quartz tin has a low value of Seeber coefficient as compared to the other two materials. As we move from silicon to tin, the band gap decreasing and the conduction of the charge carriers increases. So the Seeber coefficient is decreasing, but the electrical conductivity is increases, but decreases with temperature due to the mobility, which I have already discussed. So finally, we have calculated the value of figure of merit. So in the case of lithium, titanium, quartz tin have a high value figure of merit, which is 0.16 at 700 Kelvin, and which is less than as compared to the other state-of-art materials like bismuth telluride. But we can enhance this value with doping strain and pressure. So these are the important features of this work. Now I will shift my work to 2D material. 3D to 2D material. This work is published in Journal of Material Chemistry A. So in this work, we have designed a two-dimensional, computationally we have designed it, two-dimensional materials, scandium phosphide and scandium arsenide. So the main aim of this work to check the stability of newly designed 2D materials and to enhance the efficiency of the family of phosphorine and arsenine by enhancing the value of electrical conductivity and reducing the value of scale, total thermal conductivity or lack of thermal conductivity. So as we know that experimentally the monolayers are prepared through the exfoliation of the corresponding bulk counterparts. So if we are going to discuss scandium phosphide and scandium arsenide. So in the bulk phase, each compound is metallic and the stabilized in a rock salt and a salt structure. So if we see that other available prototype 2D materials are stable in planar, buckled and the puckered structures like a graphene, silicene. So if we will take the closer examination, so the puckered structure which is heavily distorted two sublayer of NaCl structure. So this first structure is a NaCl bulk structure, and this is the puckered structure. And third one is the planar structures like a graphene. And last one is a buckled structure like a silicene. There is some buckling content there. So in NaCl structure, all the atoms in the sublayer lie in a plane. In NaCl structure, in the first structure, all the atoms are lie on a plane. But in the puckered sublayer, the second structure is a puckered structure. In this structure, the atoms are arranged in a zigzag fashion. You can see this figure, this E figure. The atoms are arranged in the zigzag fashion with respect to the outer plane direction. As you can see in this figure, so the scandium atom of the lower layer, this one is scandium atom of the lower layer, lies exactly below the X atom of the upper layer. So in this case, in the puckered structures, atoms are arranged in the zigzag fashion with respect to the out of plane direction. So these compounds are proposed for the first time. So this is a computationally designed material. First time we propose this material. So it is very important to examine the stability of this material. For that, we have checked the thermal stability of this material. Up to this temperature, this material is stable. For that, we did MD simulation. So up to 700 in this figure, you can see that up to 700 Kelvin, this material is not broken, and there is a little variation in the bond length and the bond angle of them. So which indicates that the structures are stable up to the 700 Kelvin. So similar in the case of scandium arsenide. So we can say that these materials are stable up to 700 Kelvin. So next we have checked the dynamical stability of these materials. For that we have calculated the phonon dispersion. We have also applied a strain up to which percent of strain this material is stable. So we found that up to 14% strain we did not get any negative phonon vibrating mode. So these materials are stable, dynamically stable up to the 14% strain, and at the 16% strain we are getting a negative vibrating mode, which indicates that these materials are unstable dynamically at 60%. So first we have checked the thermodynamic stability, and second we have checked the dynamical stability. So it's also important to check the chemical stability of this material. For that we have calculated the formation energy and the cohesive energy of this material to check the chemical stability of this material. So the value
Oh, excuse me, ma'am. Yes. How many slides are remaining? Can we finish in 5 minutes?
Yes, sir.
Is it possible to finish in 5 minutes? Okay, please continue.
Okay. The value of formation and the cohesive energy is negative, which indicates that these materials are chemically stable and experimentally possible. So these are the band structures of these materials, and with increase of the strain, the band gap is also increasing. We have also calculated the fat band energies, which show the different orbital contributions, which band contributing by the which orbital. So we designed a 4-band, 1, 2, 3, and 4. And this band is due to the px and py orbitals, and this band is due to the d orbital, And this fourth band is due to the dz square orbital, and the second band is due to the pz orbital. So we have also calculated the Seebeck coefficient in both directions in ampere and the zigzag direction for p-type and n-type materials. And similar, we have calculated the electrical conductivity of these 2D materials. So for the p-type, the scandium phosphide, the value rises from 404 to 1182 as the strain increases up to the 14%. And similar, we found in the case of n-type material. So in this case, the electrical conductivity decreases with increase in the temperature. And last, we have calculated the lattice thermal conductivity of both materials. And we for unstrained materials, the value of lattice thermal conductivity is 8.27 along zigzag direction and 7.98 along the ampere direction. But at 14% strain, we got an ultra low value of lattice thermal conductivity, which is equal to 0.45. So we have already calculated the Seebeck coefficient, electrical conductivity, and lattice thermal conductivity of these materials. So finally, we have calculated the value of figure of merit of these materials. So the value of ZT is 0.79 and 0.64 in the case of ampere and zigzag in the case of scandium phosphide, and 0.71 and 0.74 in the case of scandium arsenide. So as the strain increases, the value of ZT also attain the maximum value, which is equal to 0.83 and 0.89 in the case of scandium phosphide, and 0.83 and 0.99 in the case of scandium arsenide. So this is the conclusion of our this work. So these materials are designed first time. So phonon calculation shows that these materials are diameter stable in the pocket structure, and they having the electrical conductivity in the order of 10 raised to power 3, which is 2 orders higher than of the phosphorine and the arsenide. So with the optimum strain condition, when we have a 14% strain, the value of lattice thermal conductivity is 0.45, and the figure of merit is also strain tunable, which is changes from 0.65 to 0.9 in the case of scandium arsenide and scandium phosphide, which makes these materials as a promising thermoelectric material. So these are our research group. So Dr. Shilna Timan, and she is associate professor here, and Baljinder Kaur, Adin Bindu, and Nikit. These are our PhD students, and these are our collaboration. So thank you, everyone.
Oh, thank you so much, Dr. Kulinder. Thank you so much. I'm sorry that since we have another session after this, I made you a little bit hurry in the end. Now
it's okay, sir, no problem.
Okay, thank you. Now we will go for questions, but due to time constraint, let me say only 2 questions maximum. After that, we are going for another session. And so if anyone is having questions from the talk, now we are ready to accept the question. Anyone? Do not hesitate to ask any question. If you are having any question, this is the time for it. All right. It seems no one is having any question. I think I'll.
Sorry, sir. Can you hear? Can you hear?
Yeah, the connection is a little bit weak. Yes, I can hear. I can hear.
Mr. Chairman, may I interrupt? I think
Yes,
Dr. Farooq Ahmad is having certain question. He has typed in the chat box. Let me read out the question, if you permit me. What Dr. Farooq Ahmad typed in the chat box is that, why we use 2D materials? Why not 3D in most of the cases? I think it is in relation to that thermoelectric
Yeah, I have
properties and
already
all.
discussed in density, for the density of state is depending upon thermoelectric coefficients are depending upon the density of state in 3D and the 2D materials. I have already discussed in my slide. Why 2D materials.
Yeah. Thank you, Madam.
All right. If anyone else is not there, then I think the convener will take the chairs back.
Yeah, thank you, Chairman of the session, Dr. Lorinta Rapacho, and thank you, Dr. Kulwinder Kaur, for your elaborate talk on your present research works. So I probably would also like to have further communications, because here in Department of Physics, Pashu University College, particularly me and Dr. DB are working on this 2D materials as well. So it was very interesting. I have certain questions actually, but since we are running short of time, I think we should move on to the third session. So the third session, here in the third session, we will have a talk from Professor James. Just a minute, yeah. Professor James and Professor Diwakar Tiwari. So unfortunately, Professor Savas Kaya will not be able to give his talk because of unfortunate incident in his family. And the third session will be chaired by Dr. Thakimi Zadeng from the Department of Physics, Mizoram University. So I shall now pass on this control to Dr. Thakimi Zadeng.
Thank you very much, Dr. Shiata. So as the convener had mentioned, my name is Dr. Thakimi Zadeng. I'll be chairing this session. So as mentioned before, we are going to have two invited talks in this session. So the first one will be from Professor James Jebrasilan Samuel E. And the second talk will be from Professor Diwakar Tiwari. So let me give a brief introduction of Professor James. He is a senior professor in the Department of Physics, VIT University, Vellore, India. His research interest is mainly in medical gel dosimetry. He has more than 50 publications in reputed journals. He has published a couple of books as well as book chapters. He has 2 patents which has been filed and approved. He had completed a couple of projects. He had also produced many PhD scholars as well as MPhil scholars, and a number of scholars are also working right now with him. So the topic for his talk today is in SNO2 assisted photocatalytic degradation using Arachis hypogea shell extract RSM optimization. So without taking more time, let me invite Professor James to start his talk. Professor James, are you here? So you are muting your, can you unmute? Yes.
Yeah.
I think it is mute. You have to unmute, sir. Sir, can you unmute yourself?
Good afternoon, everyone. Are you able to hearing me?
Yes, you are audible.
Good afternoon.
Good afternoon.
Yeah, thank you so much for your kind words. I'm delighted to be here in this conference, and I thank Professor Dibya Rai for giving me the opportunity, and one of my best friend, Professor Dibya Rai, and I'm here to present a few, the concepts. I think are you able to see my slide? Are you able to see my slide?
No, I don't think it is coming.
Yeah. Oh.
No, sir, you have not shared.
I have shared.
Can you please share it again, or it's not showing?
Sir, you are only sharing your web browser. So what I can see from my screen is your web browser only.
Are you able to see it now?
Yes, it's coming. It is visible.
It's visible, right?
Yes.
Yeah, thank you so much. Sorry for the, apologies for the, technical glitch. I'm very sorry. So I thank the organizers for giving me the opportunity to talk about the nanoparticles in this particular conference. So I'm presently the professor and head of the Department of Physics of VIT University, and VIT is the institution of eminence recognized by Government of India. So the title that I'm going to talk about, SNO2 assisted photocatalytic degradation utilizing Arcasis hypogea cell extract RSM optimization. So when I talk nanotechnology, and I know that there are some of the scholars, the beginners also will be there, some few introduction followed by our research work. I will present it here. And here, this nanoparticle, when we say that this is of the order of 1 to 100 nanometer, in the range of 1 to 100 nanometers. So these nanoparticles are the primary building blocks in the nanotechnology. And today, without nanotechnology, nothing is there. Whether it is industry or agriculture or healthcare or environmental, everywhere we have the nanotechnology. So there are different approaches to nanofabrication, either top-down method or bottom-up method for synthesis of nanoparticles. In the case of the top-down, we are breaking down the bulk material into a nanoparticle, reduction of the size, and in the case of the bottom-up method, from the atomic scale, we are building up the nanomaterial. And there are different methods in which we have either physical method or chemical method or biological method. There are some of the disadvantages in the case of physical method and chemical method, where the physical method is time and energy consuming, and in the chemical method there are a lot of harmful things will happen. That is the reason that we are going for the biological method. And this biological method is a green synthesis method, highly economic, and we can control the toxic level, and there are a lot of advantages. And this is a green synthesis material, and they are very highly stable, well characteristics nanoparticle. So when I say that biology, here we are talking about more on the green synthesis method. There is a bioreduction. Now, why we talk about these nanoparticles? So today, the place where we live in Vellore, it is a completely threat to the society, because there are a lot of organic effluents are available here. We have a lot of tannery industries, we have pharmaceutical industries here. So what will happen is that the organic effluents are the threat to the environment, and they cause severe damage to the surroundings, not only to the surroundings as well as to the mankind. So the toxic pollutants they are dumped into the water, not only to the water, atmosphere as well as in the land, because by the polluting the industries, as I mentioned about whether it is leather or pharmaceutical industries. So this is a main problem. So when we choose a research area, we have to choose the societal problem we have to choose. So here we have chosen, the societal problem. So what we have taken is that the dyes are involved in the case of the pollutants, organic effluents, and these are all non-biodegradable dyes, and these dyes contribute major share among the effluents. And as I said that they are non-biodegradable, these dyes, they affect the quality of life, and they are very much harmful to the human beings. And we don't have the clean water. That's a problem. For drinking purpose, we don't have the clean water because of the pollutants, lot of pollutants. So there is an increased demand for the clean water. So that is the reason that because of the increase in the demand of water, we are going for the photocatalysis process. That is a green approach method with respect to the conventional methods. That's what we are going for, the biological method. And where the usage of nanoparticles is safe and eco-friendly for the degradation of the toxic effluents. So we have identified the gap. What is the gap here? And we are using the nanoparticle synthesized from the plants. Now, why we are going for the plants? Because they are all less toxic. And today in India, people are more inclined towards television. Whatever the television, when they advertise, people, whether it is, they won't see that whether it is real or fake. Most of the things are simply on seeing the advertisement, from the kids to the adolescents, old age people. On seeing the television, something comes into the market on television, people simply believe that, right? So this is the problem in our system, because our culture, our ancestors, they have devised the method, everything is perfect in the life, but we forgot everything. For example, if you take the groundnut is multiples are there in the entire world, 34.43 billion metric tons every year. But what will happen that we are lot of agricultural waste. In India, we are doing lot of agricultural waste. So the objective of my talk is that to synthesize a photocatalyst is for tin oxide nanoparticles using the hypogea, using the peanut or the groundnut, and to check the antifungal property and to check the photocatalytic activity, and also to find out the influence of operating parameters for the RSM optimization. Now, why we choose this SNO2, tin oxide? Because there are plenty of applications. Application is very, very important when you choose the material, whether it is solar cell or MRI and magnetic data storage, liquid crystal display, or the sensor application, or optoelectronic device, or catalysis. Everywhere it is applications. So with our biotechnology department, we have find out what is the classification of the plant, what we choose, and these are the classifications, the subfamily, and everything we have taken that. And groundnut are rich in antioxidants. Not only that, they are rich in vitamins, minerals, and protein. People say that, in the advertisement, they say that, refined oil is good. No, but here when you use the groundnut, it lowers the bad cholesterol and increases the good cholesterol in the human body. So groundnut oil, our ancestors, they have used the groundnut oil. So we have to follow the groundnut oil. It is used to lower the cholesterol and prevent heart disease. This is very, very important. Not only heart disease, it reduces the weight loss and it decreases appetite. So there are a lot of advantages. So that is why we have chosen this groundnut for our purpose. And this is the material that we have taken. See the wastages, the shell, what we have. So we have taken into the powder form. So we have taken the shell extract, and these groundnut shells are completely washed and dried, and so that no dust particles should be present there. And we have stored it, and then we have crushed it and the powder, and also we are adding 20 ml of petroleum ether because this is must for to take out the hydrocarbons. So we have treated it with methanol. The secondary metabolysis were help for the preparation of the nanoparticles. So this is how we are going to do the nanoparticles. So if you see the nanoparticles, the first one in the case of GC, the gas chromatography, when we find out that, if you see that, because why we take this particular nanoparticle, because this is responsible, the phenolic group, and the group is that the phenolic group and acidic compounds in this material, they are responsible for the SNO2 nanoparticle formation, and they are acting as the capping agents. So the GC, from that we confirm that the phenolic group as well as the acidic compounds, they are responsible for the tin oxide nanoparticle formation, and they are acting as these capping agents. So this is the methodology which we have followed. The synthesis of the tin oxide nanoparticles, we have taken 20 ml of methanolic extract, and then adding the hypogea, the groundnut, and 80 ml of 1 mm of SN chloride, and we maintained at 60 degree by means of centrifugation and calcination. Then we got it the SNO2 nanoparticles. So this is the methodology, and we will go for this UV visible spectroscopy. If we find out that the absorbance of the order of 200 to 800 nanometer, and here the absorbance peak for every 10 minutes we have observed that, and you can see that the clear solution to precipitated solution as the time increases. So as the time increases, what will happen that the precipitated solution, clear solution will come out. That's the reason that confirming this UV visible spectroscopy. And we are able to get the band gap using the tau plot. And if you see the tau plot, we are able to get the band gap value of the order of 3.1 electron volt, because this material is very much useful for the band gap of the order of 3.1 electron volt. This XRD value, the JCPDS value of 880287, which is having the tetragonal phase, and we have the HKL values of all the planes 110, 101, 211, all the planes which I have mentioned, and no extra peaks were found. And this is the confirmation that we have found out that, and the Fourier series where we are able to get the different functional groups. We are finding out which functional group is responsible for the formation of the nanoparticles, and the SEM and the TEM. We are able to have the morphological studies which is helping us for the SEM, where we clearly indicates the amalgamated particles, and in the case of the TEM analysis, we are clearly indicates the nanoparticles, they are in the spherical form. And we are taking this SAED that where we are talking about the selected area electron diffraction pattern, selected area extraction diffraction pattern. It confirmed that the HKL values were in agreement with that of the XRD results. So that is why we have taken SAED, selected area electron diffraction, and we have taken for the particle high size histogram, and this histogram synthesized nanoparticles distribution was found to be between 60 to 65 nanometers. So that is also one of the area, I mean, how we have gone through that. And also we have gone for the, I mean, various possible mechanism. This is how we have taken the materials. You see that taking the groundnut, and the process is that the acidic compounds, as I mentioned, the acidic and the phenolic compounds group, they are forming, the helping us formation of the SNO2 nanoparticles. The acid or the phenolic group in the plant, it reacts with stanium chloride, and then we are able to get the tin oxide nanoparticles. And the antifungal activity applications also, it helps us for various percentage. We are able to calculate the percentage of inhibition, and we are able to have the graphical representation as here you can see that. And this result has clearly mentioned, that it is an eco-friendly, and this is what is very, very important. Fine. And here we are having this diagram. You can see that the Congo red photocatalytic degradation. See, the Congo red degradation was performed with and without SNO2 particles. The first diagram with SNO2, without SNO particles, and here you see that with the nanoparticle SNO2 particles. And here we can see that exactly at 365 nanometer, the presence of UV light you can able to have at 365 nanometer. So for every 10 minutes we have done with that of the dye without nanoparticles and with nanoparticles, and we are collecting the sample for every 5 minutes. We have collected the sample and we have done that, and the spectral degradation we have noted down between 200 to 400. We can able to find out that, and this is one of the area where we were able to find out. And our method of SNO2 nanoparticle prepared with this groundnut, the peanut shell extract, it showed that a very good percentage of degradation when compared to other methods. So this is the advantage of the waste material into a wealth material. I mean, everywhere when you take the ground out, you just throw it. It's going to the dustbin. But that material is acting as a photocatalytic degradation when you prepare a nanoparticle. That is the main advantages that. So this is how, I mean, in the various scenario, we are able to get the degradation formula, the kinetic study, and the mechanism of the photocatalytic activity. How the mechanism of the photocatalytic activity happens here. That's what I wanted to explain here. See, the electron transfer reactions involved in the photooxidation group. The electron transfer reactions involved in the photooxidation group of Congo red with that of the oxygen are. So this is what we have done that. So when we have done that, here what will happen that these SNO2 nanoparticles are exposed to UV light. These SNO2 nanoparticles, when we expose to UV light and having its energy above the band gap energy, it gets excited here. When the light falls on here, it gets excited and it forms an electron hole pair in the valence and the conduction band. It forms an electron hole pair in the valence and the conduction band. So what will happen that the hole with high activity, it can react with the hydroxyl groups. The hole with high, it can react with the hydroxyl group or H2O here, and which are adsorbed on the SNO2 surface, which are adsorbed on the SNO2 surface and forms hydroxyl radicals which have strong oxidizing activity. And this is what they're acting as the oxidizing agents, and they are responsible for the degradation. So this is how it is very, very important. It happens here. So the main advantage of here, the experimental design, what we have planned, and it is having the degradation. We have the different parameters we have taken that, and that's what we are able to succeed in that. So here we are going to talk about how we are going to have reduced the this table. If you see that there are different concentration of level, low level, medium and high level, how the dye concentration and the nanoparticle concentration, how much time it is involved in that. So if you see the table 1, we have a 3-factor box here, and this 3-factor box developed by Bengen design, and this is used to with Minitab 17. We have done software, and this corresponding range of independent parameters help us to have an idea of how much amount of degradation on the surface morphology. So that is what this is very much useful. And again, you see that how this is observed response for degradation in the different area. So this is the table 2. So the response surface methodology, that's what I'm talking about, the optimization RSM. And this is what it is very much useful, and we are able to fit into the proper curve, and this curve plays a major role. So this is what we are able to do, that the degradation, and our research group, they have done an excellent work, and they fit it, and then they find out they are degrading. And here you see that the residual plots versus the degradation, and the difference between the predicted response as well as the observed value, and we call it as the residuals, where we evaluate the adequacy of the model, and the residuals are expected to occur according to the normal distribution system, and they have the fitting in the curves. And here you see that the observed residual versus the expected values. If you see the curves, we can see that this histogram where I have mentioned earlier, it was 65 nanoparticles here, and this RSM plays a major role. This RSM plays a major role. And you see that the different parameters we are using that. I mean, each and everywhere we are using the different parameters. And when we use the different parameters, it confirms for the dye level decreases to a large extent. Even a degradation of the dye up to the order of 1 to 1.25 mg, it has an efficiency in the decrease in the dye. So that is what we are including the parameters, slow of percentage of degradation using the photocatalyst concentration. And here if you see that the other level parameters, when we use here, the percentage of dye decrease, again it is getting decreases here. And again when we go for the degradation, the different parameters for different degradation, starting from the level of the adding of the nanoparticles, and when we add the nanoparticles at 50 minutes time, that is what we have observed that, and we found out that exactly at 50 minutes down, 50 minutes, there is a lot of degradation of this gango red dye. That is what the polluted water, we were able to get converted into a clean water. So this is what we are able to do that. So the very important concept which is involved here is that you see that you are taking a shell and with stannic chloride converted into particles, I mean SNO2 nanoparticles, and we characterize and the fungal activity, and it acts as a degradation. And this is what is very much useful here. So here we wanted to say that the nanoparticles which is having the size of 60 nanometer, which are in spherical shape, this plays a major role. The agricultural waste is converted into, I mean, decreasing the pollutant of water. So the GC level where we find out the acidic and the phenolic group is very much useful for the formation of nanoparticles. And these nanoparticles which have the dye, you see that 89% of degradation we were able to find out. So we have done a lot of experiment on this. We have fit into various fitting mechanisms, the surface methodology techniques we have done for the, I mean, fitting method. We have gone for the, RSM, the surface methodology. We have done that, and all the results we are able to find out well fit into the curve that we are having nearly around 89% of degradation. So this, moreover, that this nanoparticle, it is having the good antifungal activity against Niger, which makes an excellent fungicide. So this work has been coming out, and emergent value of the metal oxide photocatalysis, and this gives a very good result that SNO2 is acting as a very good photocatalyst. So with that, I want to conclude, and I want to thank the DSC for giving the permission to have the project, and Professor Mohan Rupan, and I wish to thank our Honorable Chancellor and the Vice President and all our dignitaries in VIT, and this is what the references we have. So now we have a question and answer session. Please feel free to ask the questions. Thank you very much.
Yes, thank you so much, Professor James. So we have quite a good amount of time. We have around maybe 10 minutes extra. So if anyone has some question, you may ask, you may unmute yourself and ask, or you may post it in the chat box.
Ma'am, I can see somebody raising the hand. Ankush Sharma, can you unmute?
Yes.
Can I ask the question? Hello, are you listening me?
Yes, please.
Sir, I want to ask a question.
Yes.
Sir, you are using SNO2 for the Congo red dye degradation. Have you used with the different? Have you used with the different percentages of photocatalyst, or just you use 1%? Means same amount. Understand what I mean? What I'm asking?
No, I mean, yeah. No, you want to see that whether we have used only 1% or different percentage of gango rate we have used. That's what you're asking, I suppose.
Yes, sir. Yes, sir.
Am I correct? Yeah, we have gone through various percentages and find out which one will be the best one. Accordingly, we have taken that.
Okay. Okay, sir. You show some slides about the frequency slide. You show me in the slides. Can you show me again?
Yeah, please. Sure. So which one you want? Could you please?
Frequency, about the frequency you was asking some. You was told me something.
Are you able to see the slide?
Yes, I think, but I did not see the frequency. Last 4 or 5th slide, I think so.
This one?
Yes, sir. Please, this one. Yes, this one.
Yeah.
So can you? No, sir. Back. Frequency. No, sir. This one, no. Yes, this one. Yes, this one.
Yeah.
This one, sir. This one. Sir, can you explain how you explain this frequency? Can you explain this one?
You talk about the frequency?
Yes. Can you explain this one once?
See, I have shown you the various tables which we have taken, various values we have taken. Right?
Yes.
You see that the table 1, 2, 3, 4, and 5. So what we have done is that we have done with the different percentage value, and using the software we have fit into the various models. Okay, so that's what, if you remember that I have used the method which we have used is called as the 3-factor box Benken design model, where we have taken for the observed response what is the percentage of degradation. Fine.
Okay, sir.
So what we have done is that we have fitted into the various levels and we observe that how much amount of degradation that occurs there.
Okay, sir. Thank you so much. Actually, I am also working on this one. I will contact you, sir. Okay. Thank you, sir. Thank you so much.
Yeah. Most welcome. Yeah.
Thank you, sir. Thank you. I'm from Taiwan and TUST University.
Okay. Yeah, I'll share with you my email ID. You can surely. We can work together.
Sir, please. It's my pleasure.
Your good name, please, sir.
Thank you.
Yeah. Your good name, please, sir.
Naveed Ahmed, sir. I'm from Pakistan, but I'm doing PhD in National Taiwan University of Science and Technology, Taiwan.
Okay. Most welcome.
Sir, thank you. Bye, sir. Bye.
Thank you.
Sorry for this interruption.
Bye.
Okay.
Welcome.
So, questions from other participants?
Ma'am, there is a question in a chat box.
Okay, from Ankush Sharma, right? Okay, I'll read out the question. How the study can be directed into future? Professor James, the question is...
Yeah, could you please repeat the question, ma'am? How
the study can be directed into future? It is in the chat box.
Yeah, it's a good question. Yeah, it's a very good question. See, I told you in the beginning, in the area of where we live in Vellore, we have a lot of tanneries. So when we took the water and find out the sample there are a lot of effluents are there. So, and we find out what are all the elements that are present here. And accordingly, we find out that what are the elements to be, it should not join in the, the river. So we have given a recommendation to the Pollution and the Control Board. What are all the elements it should not harmful? What are the elements which are harmful to the mankind? So accordingly, before the water that has to come out from the tanneries or the effluents, and they have to refine it, and then they have to, the water has to go out. So in future, all the tanneries, the Environmental Board has given a clear warning. You should not send the water as it is. These are all the things that, and that is what using the dye with nanoparticles along with the effluents wastewater, if they add, the contamination will be very much reduced. so that the diseases can be very much reduced. So this is the main advantage of using these nanoparticles in our system. I hope that I have answered your question. Ma'am?
Yes, thank you so much. Any more questions? There is a suggestion, a request from Naveen Aman in the chat box to put your email in the chat box if possible, Professor James.
Yes, just a second.
If there are more questions.
I think you all got it.
Yes, it is there. Thank you so much. So, any more questions?
Welcome.
From the participants? Any more questions?
Ma'am, can I ask a question?
Please, yes. Go ahead.
Yes, sir, please.
Sir, how did you recover? Is there any way to recover the photocatalyst?
Any way to recover?
Recover the photocatalyst for its reusability, sir.
You want, whether the photocatalyst can be reused, right? That's what the question.
Yes, sir. Yes, sir. Was the main property of a photocatalyst is that it can be reused for multiple uses. That's the main application of the photocatalyst. If it can be used only a single time, then it is not very advantageous now.
No, it is not a single time. You could use multiple time, but as the time goes, it has everything in the world. It has a lifetime, right? So we can use it maximum of maximum time, but as the time goes, the reaction process will happen fast. So we can have these photolytic catalysts. We can have more time compared to other materials, and especially the material which we have taken from the groundnut, especially the natural product. It has a long-lasting life compared to other material. That's why we have taken the methodology. When we prepare the material itself, we have not gone for physical method or chemical method. If you go for physical method or chemical method, the lifetime is less. When you go for the biological method, the green synthesis method, the lifetime is more compared to other materials. That's what we have chosen this material. So this photocatalytic material which we have taken from the green synthesis method has a long lifetime.
Okay, sir. Okay, thank you.
Okay, can we have one more question? Okay, I think there's no more question. Thank you so much, Professor James. Thank you for your very interesting talk. And your topic has really huge impact on the environment, and I'm sure it will have more impact on correcting the environmental pollution which we have caused. And so once again, I thank you, Professor James.
Thank you, ma'am. Thank you very much. I would like to thank the organizers of this conference for taking special efforts during this period. And without traveling, we were able to contact the entire globe. This is the opportunity that has been given by God. And my sincere thanks to Professor Dibya Rai, who is organizing this conference, a good friend of mine. I thank him so much for giving me this opportunity. And I thank ma'am for you for taking this up, giving an opportunity. So thank you once again for all of you. Let us collaborate. Each one of us will collaborate in the days to come. So that is the opportunity. This is one of the big opportunity, and VAT is a place to learn, a chance to grow. So we can have a very good opportunity. So thank you very much. Thank you one and all. God bless you.
Yes, God bless. Thank you. So we'll call the next speaker for this session, Professor Diwakar Tiwari. Is he available?
Yes, then let's see.
Okay, sir. Before your talk, let me give a brief introduction. So Professor Diwakar Tiwari is a professor of Department of Chemistry, Mizoram University. He's also the Dean of School of Physical Sciences, and Professor Diwakar Tiwari had completed his PhD from Banaras Hindu University, Varanasi, India. And his research interests includes hybrid functionalized materials in environmental remediation, development of electrochemical sensors for arsenic, ferrate in the waste water treatment, radioactive waste management, study on standard solutions by primary methods of measurements. He had published more than 100 articles in reputed journals as well as conference proceedings. He has been a visiting fellow as well as a visiting professor to a couple of foreign universities. And he had talked in various international conferences as invited speakers. He had completed a number of research projects as well. So, and he also had produced a number of research scholars, PhD scholars, and a good number are working with him right now as well. So the topic for his talk today is nanocomposite materials in the development of electrochemical sensors, detection of pharmaceutical compounds. Sir, you may proceed with your talk.
Thank you, Dr. Chatang, for your kind introduction. She is from our school only. And I am very much thankful to the organizers, especially Dr. Rai and all, inviting me, giving me this opportunity to discuss what we are doing in this place in Mizoram University. So that I would like to share today. It has been asked to me that to be completed within 30 minutes. I'll try to discuss certain things in this duration. So can I share, Dr. Chadang, my slides?
Yes, sir, you can share your PPT. I have given you a co-host.
Okay. So we'll stop other system. We'll continue. Is it okay, madam?
Yes, it is visible. Yes.
Okay, thank you. I think now it is visible and I'm audible also. So as she mentioned that I'll be talking today about the nanocomposite materials in the development of electrochemical sensors and detection of the pharmaceutical compounds. We are working in the different type of the compounds, especially the micropollutants and the different, say, arsenic or the cadmium or the heavy metal toxic ions and all that. Their detection, their removal and all that, the photocatalytic and those things, all that we are doing, including this, the ferrate technology and all. So at present, as she already mentioned that the Dean School of Physical Sciences, but in addition to that, I would like to mention, because this is relevant in Northeast, especially that I'm looking after this as a director of the DRDO Northeast Science and Technology Center. This is fully supported by the DRDO, and this is facilitating in this Northeast region for the providing the funding. But of course, the project has to be directed towards the the futuristic research, especially for the defense personnel. So we welcome through this Northeast Science and Technology Center to submit the proposals, and soon we will be giving the next call. Earlier, we have given the call, and almost that I am very happy to inform that more than 10 proposals are accepted and all. So soon that will be finalized. So this is the opportunity for the researchers, those who are working in Northeast area. So this is our department, and the school building is on the left-hand side. Right-hand side is the department, and if you enter my research laboratory, just right, the first laboratory is my laboratory. So I will be discussing and my contents of the presentation that includes the motivation, how we have been motivated working in this particular area, and then a small introduction, methodology that what we have adopted, followed by result discussion and the conclusions. So how we have been motivated, we have gone through, if you see that one of the article which was published in India Today on September 29, 2015, that has attracted the attention in the country. It is stated, of course, the global attention was there much earlier, but this in country, they have stated that a new study has revealed that endocrine disrupting chemicals, which is, the class of the chemicals or the class of the pollutants, I will say, that contribute to health problems by mimicking, blocking, or otherwise interfering with the body's natural hormones. It was further stated that EDC's exposure is connected to infertility, hormone-related cancers, neurological issues, and other disorders. So known as EDCs, as we all know about the bisphenol A and all that. Okay, this is nowadays, if you try to see that most of the time in the, the plastic bottles and all, they used to say bisphenol A free or BPA free. So like that it comes. So now the concern has coming into, in addition to this, the micropollutants. In fact, the micropollutants, it includes all these EDCs, it includes the pharmaceutical compounds, it includes the variety of, I can say, personal care products and all that. So in general, what we used to say that the micropollutants, which are of course at the low level, I will be coming that how it is entering into our aquatic environment and all that. So micropollutants are the organic or the mineral contaminants of the anthropogenic or the natural origin that can be harmful to human health as well as the aquatic environment. They can be found at very low concentration in water and are generated from industrial processes, pharmaceutical manufactured for human use and veterinary drugs, personal hygienic products, industrial or household chemicals, etc. and all that. So this is, I would like to share, this is the conventional treatment plant that we will be having, or that is, globally, of course it is. This is, if you try to see that there is a primary unit, in that primary unit, whatever the sewage plant, industrial waste and all that. So there is a primary unit or primary tank, which is a sedimentation tank where the sedimenting, the materials are, or the pollutants are sedimented and has been removed. And then if you come to the aeration tank in the secondary, the treatment as well as this aeration tank, here the biological activity is being grown here along with the aerated, so that the whatever the degradable compounds are there, that will be degraded here. And then the secondary treatment with that, the heavy metals and all that, they try to remove it, followed by this chlorination, and then the effluent will be coming out. And that effluent people are using for agricultural purposes, or sometimes this is the influent for for the drinking water and all that. So this is the simple arrangement of the wastewater treatment plants. But what happens, there are the certain chemicals which are not, or maybe they are persistent and they are not completely degraded or partly degraded only. So they are coming out, and that is nothing but we can say that those are the emerging pollutants. So these are, in a brief, we have mentioned that they are coming in. These, the micropollutants, they are at the nanogram level or up to the microgram level. So they are coming through the wastewater treatment plant. And the concern is there. Concern is that how to remove that. Okay. So to protect the, the human health and all that. So this is the micropollutant as a simple way we can understand it, that the anthropogenic or the natural substances, the pharmaceuticals, personal care products, the hormones, the antibiotics, the pesticides, industrial chemicals and all that, these are all known as the emerging micropollutants. And you see that there is no discharge guidelines is being stated, even if you look at if you try to see that what is the standard or the maximum permissible level and all that, there is no certain guidelines at the global level also. If I was looking into the EPA and all that goes, the guidelines, there is nothing has been given. But if you look at the pathway of this is say residential, the residential waste and all that, through this septic and all that is coming through the leachate, and then it will be coming into the aquifer, and aquifer are being contaminated with this, the micropollutants. Or if you try to see that the, the municipal waste and all that, there is the sewage treatment and all that facilities are there, or the waste which is coming from the health care units and all that, and from there the sewage, what the waste is coming here, we can see that, okay, it is treated here, but some seepage and all that, through that it will be discharged coming into the groundwater, and groundwater is being contaminated, or through this sludge and all that, which is coming through this agricultural runoff and all that, contaminating the aquatic environment and all that. So this is the way by which the, the pharmaceutical compounds and all that, they are coming into the aquatic environment. The question is that, so once this is slowly it is accumulated, so what happens? Suppose the antibiotics are coming, if you're in your water bodies, if antibiotics are there, those antibiotics, if they are coming into the drinking water, and slowly if you are taking, then the resistance is going to be, decrease, or the resistance will not be there in future if you are taking in a prolonged period, if you are taking this, the water which is contaminated with this. If you look at the, the article which was published in the country, that the micropollutants in the groundwater are grave concern. A study finds that a number of the locations in the country have high concentration of the micropollutants in groundwater, posing a risk to health and environment. If you try to see that the groundwater pollution due to organic micropollutants is becoming a major cause of the concern in many parts of the world where water resources are on the decline. India is the largest user of the groundwater, and the presence of micropollutants in groundwater has been a growing concern. So nowadays, this is a, it's a big concern. I will say that the micropollutants in the groundwater or even in the surface water, that is also being contaminated with this, and there is no proper, the detection and all that of these the pollutants. This is the something which the data that we are having. If you look at that, so we can see that this is the global picture. How many number of the pharmaceuticals detected in the surface water, groundwater, tap water, and or the drinking water. If you try to see that some of the region that has been not been detected, or the no data is being available, okay, in certain parts, say African and all that, but in the country it is more than 31 to the 100 micropollutants of the pharmaceuticals are being detected, and they are posing a serious concern for the environmentalist. This is the endocrine disrupting the compounds, surfactants in groundwater and all that, or phthalates, or the polyfluoroalkyl substances and all that. So personal care products are there, artificial sweeteners is there. So PCPs, that is the personal care products, that includes the shampoo, toothpaste, lotions. For example, we have done a lot of work related to the triclosan. Triclosan that is also kind of the personal care products, has been used for a wide range of the of the products. So that also we have tried to do it. So the other slide, other way, if you try to see that, how to make sure your water is safe to drink. This article was a very interesting article I was looking into. So safe to drink when you are pregnant. This was written by Maria Masters. So medically, okay, the quality and the quantity. That's very important, that the quality and the quantity of the water you drink is more important now that you are hydrating for two. Here is what you need to know about what comes out of your tap. So what we want to say that what we are getting through the tap, or what the water sources that we are having, how safe the water is there. So that is the important point that we have to look into. So we wanted to work to see that, okay, and we were working in this area, that can we detect this. Of course, there are the certain techniques which are available. For example, the HPLC is there, or ICMSAP is there. These techniques are there. They are very sophisticated instruments are there. With that, we can detect it. But the question is that, can we, each and every sample can be sent to the to the sophisticated laboratory, and that has to be detected, and then that can be that it's not that feasible. So we wanted to see that, is there any possibility of developing a device which is a miniaturized device by which we can detect the micropollutants at that low level which is required. So this is the couple of the drugs that we have targeted this time. That I will be discussing. This is the sulfonamide drugs, which is an antibiotic, the broad spectrum of the antibiotic that has been widely being used for the antibacterial activity, free amino group, growth promoters in the livestock and all that. If you try to see, this is the two different, the sulfonamide drugs are there, sulfamethoxazole or sulfamethoxine, that we try to work on this, and I would like to share some of the the outcome of our research in this particular area. So what do I wanted to say, that the proper monitoring of these pollutants in the aquatic environment is very crucial and very important also. Of course, the instrumental techniques, as I mentioned, that the conventional techniques, I will not say that the conventional technique, but it is the, the sophisticated techniques, that is the chromatographic techniques, say HPLC or LCMS, and all this, that can be used. But what the disadvantages are associated with this, that is the sophisticated instrumentation, cost, too much cost is required, expensive in operation, and it takes a lot of time consuming and non-portable, which is a very important. You cannot port the instrument to the site where you want to detect or where you want to do the monitoring of your water. Okay, so require skilled personnel for the proper operation. On the other hand, if you try to see that the electrochemical techniques has drawn much attention in recent years, this offers advantages such as the portability, sensitivity, simplicity, cost effectiveness, and very easy handling. I'll try to show that we have done, and we have commercialized also the device that I would like to share a little bit here. This was our objective, that we wanted to modify what we wanted to do. We wanted to develop a material, and that material we were trying to use for the detection of the micropollutants or these pharmaceuticals or these drugs. So for that we have used the electrode, and that electrode surface we try to modify it in such a way using the materials. With that, the improved the sensitivity or the selectivity we will be getting. So this is a simple picture that. So strategy was a very simple, that synthesizing the material and preparing or the synthesizing the composites, and then the fabrication of the microelectrodes, and then the sensor development for the trace detection, optimizing the data and all that, and try to see that the enhanced the sensitivity. So this is the objective, or this is the strategy that we have adopted. As we know that we have worked a lot on the clay materials, the natural clay materials, which are the phyllosilicates. The phyllosilicates, where this tetrahedral, the silicate is there, and the octahedral aluminates are there. They are stacked together, forming a layer structure. In between, there are the exchangeable cations are there. With the help of this exchangeable cations or the terminal hydroxyl group, that we try to functionalize the material, and then that functionalized material we have tried to use for the various the applications. For example, the photocatalytic also we have tried to do. We have done the removal of the advanced material or the hybrid materials, and then we are trying to use the different kind of the materials for the the detection and all that. So these are the area that we are doing. So what a simple methodology that we have adopted here. First of all, what we have done, we have obtained functionalized it using the organic silane and the bentonite, and we have collected some of the natural, I will say that locally clay also we have collected, and then we have the clay extent we have increased it, and then we have applied for the different applications also. But this is the bentonite we have obtained commercially, and then we utilized it. So this bentonite, it was washed, and then it has been 10 ml of the silane in the inert atmosphere. We have in presence of the toluene, the organic solvent, that we have obtained the nanocomposite material. That means that it is incorporated and it is forming a strong bond with the bentonite, and the leaching problem will not be there. Sometimes what happens, we were trying to exchange the cations with using some kind of the surfactant molecule. In that case, there is a possibility always that it is physically bound on the surface, and then slowly the leaching it out. But this is forming a chemical bond. With that, what happens, the leaching problem is not there, and that can be more stable, the composite material. Followed by that, what we have done, we try to use this try to obtain the nanoparticles of the silver or the gold using the precursor of their the salt ions, and their salts and the aqueous solution that we have used, and then the avocado leaves that we have collected and dried, and the extract was taken, a small volume of this extract, and this extract was characterized also in terms of especially the what I can say that the qualitative estimation that we try to do it, and it includes with the alkaloids or the tannins and saponins and flavonoids and all that. This we can see that these are the positive results are being shown here, and then we try to use this, the extract a very less volume, that is 0.25 microliter of this extract in 20 ml of the 2 millimolar of the precursor solution, and then at 40 to 450 degree, it's a very low temperature. Sometimes at the just 40 to 40 degree, in 60 minutes, this has been converted into the nanoparticles, or the colloidal solution has been formed for the silver and gold. And then we try to introduce this silver and gold nanoparticles with this, the composite material. It's a very simple method that we have adopted here. 10 gram of this, the composite material we obtained using this trichlorooctadecyl silane. This is the organic silane that we try to introduce here, and this the composite material along with the nanoparticles that we have added, and then it has been stirred for the 24 hours and collected and dried at 60 to 80 degrees C. These are the two composite materials that we obtained. One is that the silver based, and the other one is the gold nanoparticle based, the composite materials. So silane modified bentonite plus metal nanoparticles, we can say that. And then what we have done, the glassy carbon electrode, we have used it on the surface of the glassy carbon electrode. We have coated the material or impregnated on the surface of the electrode, that is the glassy carbon electrode. Prior to use the glassy carbon electrode, it was cleaned using this diamond or the aluminum solution, and then sonicated and all that with the ethanol or the distilled water. Then we washed it, and then we have coated it. For that, what we have done, the modifier solution, we prepared it 4 milligram of the composite plus 4 ml of the mixed solvent, 1:1 DMF and the deionized water. This you can see it here on the surface, and then evaporated the solvent, and then there is a firm, I will say that is a very stable, the coating has been obtained. That is the casting, we used to say that. Okay, so that is called as the drop casting. The drop casting method we have adopted, and through that you can see that this the electrode we have used it. So these are the results and the discussions I briefly and I would like to discuss here. This is the UV visible spectra that we obtained for the nanoparticles which we have obtained, say silver or the gold nanoparticles. You can see that the characteristics, the peak has been obtained somewhere around in the visible region. That shows that the formation of the silver or the gold nanoparticles took place. And this is the materials, the different materials. What I can say that the bentonite is there, the composite material which has the bentonite, which has been grafted with the silane, and then the silver and the gold nanoparticles base the materials, the nanocomposite materials, and they are the IR peaks that we have obtained here. And with that, we have confirmed that the organic silane has been introduced here. These are the characteristic peaks which we have been obtained, that is giving the CCS2 group of alkyl chain, aliphatic chain of the organic silane that we obtained. These are the some images that we have obtained. This is the bare GC, the surface of the GC, and then this is the bare GC. And when the bentonite is there, you can see that the surface of this is having a very compact structure is there, or compact surface is there. And then when we have introduced, of course it is a bit porous material, but when we have introduced the silanes, this has been occupying with that surface as well as within the pores and all that. And here we can see that the silver or the gold based the surfaces or the materials. This what we have done, the powder we have used for the SEM images. What the way we have taken the glassy carbon sheet. On the glassy carbon sheet, exactly in the same process, we have modified it or we have casted it, then we obtained the SEM images. We have not taken the electrode for the SEM images. So here we can see that more compact is, of course, the structure of the heterogeneous surface, as well we can see that the silver or the gold nanoparticles, small particles is being occupying on the surface. But when we look at the TEM image, this is the elemental, the composition with, this is the bentonite and then the TCBN or the composite material. In that the composite material, the chloride peak has been obtained, or the with that we can confirm that. And here is the silver and the gold peaks are obtained in the silver or the gold based the nanocomposite materials. We can confirm that the silver and gold has been introduced within that the composite material. And these are the TEM images that we obtained. The TEM images, the particle size are very uniform. The spherical type of the silver or the gold nanoparticles is being obtained. Size of the nanoparticles, somewhere average size, I can say that somewhere around 20 to 25 nanometers. And then the, the D spacing is somewhere around 0.12 nanometers. So very good fringes has been obtained, and here 0.2 nanometers. And the AFM analysis that we have done to find the roughness of the surface. So that this is again, we have used the glossy carbon sheet on that surface, which we have been coated, and then we try to obtain that how much, what is the surface roughness. Surface roughness was for this, the silver and the gold based the film, it is around 17.6 nanometers and 11.9 nanometers. We obtained, these are some other pictures of the TEM images of this, the powder of this, the materials. And then we try to use this, the electrode for the electrochemical behavior. We try to see that how is performing how is the electrochemical behavior of these electrodes. For that, we have done the two different measurements. One, we call it the scan rate studies. So we have increased the scan rate, say from 20 or 40 millivolts per second, 50 millimoles per second to the 200 millivolts per second. Then we try to see that how does it behave. Of course, naturally it is increasing the oxidation and reduction. For that, we have used the the standard solution of the ferrous and the ferric cyanide 3 plus and the 2 plus and 3 plus, the iron that we have used. And through this, the Rendell's and Savick equation, using this Rendell's and Savick equation, other quantities are known. IM is known, that is the current, the peak current, and nu is the the scan rate, D is the diffusion, C is the concentration that we know, the bulk concentration, N is the number of electrons involved, that is the one. So A, the area, surface area that has been obtained. So for the differently, the modified electrodes, we try to obtain the surface area. On the other hand, the EIS measurement that we have conducted using this Nyquist class, that is the, the equivalent circuit, that is, this is the solution resistance, that is the capacitance, double layer capacity, and then the charge transfer resistance, the Warburg, the resistance, and we try to correlate with that, and we try to estimate or optimize the values of the RS or the CDL or the RCT values or ZW values. Then we try to see that how does it behave, the modified materials, the modified electrodes, fabricated electrodes. This is the scan rate studies data. With that, we have calculated the surface area. If you try to see the surface area, significantly the surface area has been increased comparing to the bare GCE glossy carbon electrode. The surface area is almost 3 times has been increased. On the other hand, if you try to see the Nyquist blast, which is giving the semi spherical the behavior, we can see that significantly this has been decreased. With that, we try to optimize the different values like the RS value, CDL value, and the RCT value. RCT is an important quantity, that is the charge transfer resistance at the surface of the electrode. How does it behave, or what is the resistance, the charge transfer resistance? If charge transfer resistance is low, it's more easy or feasible for the electrochemical process to take place. So here we can see that the charge transfer resistance is significantly decreased comparing to the bare GCE. Bare GCE, the RCT value kilo ohm, that is the 16.53. Now it has been decreased when we have used the silver or the gold based material. It is 3.22 and 3.13. So that is a significant decrease we have obtained. Now we try to use the electrode for the purpose of the detection of the sulfamethoxazole and sulfamethoxine. So sulfamethoxazole, you can see that on the left-hand side, right-hand side is the sulfamethazine. How does it behave? So what we have observed that it's a good oxidation. Of course, it is taking place somewhere around the potential is somewhere around 1.2 and all. So sulfamethoxazole, it is going to be, oxidized. But on the other hand, there is no reduction is taking place. So what we have, what we can conclude here, that a kind of the irreversible process, electrochemically irreversible process that is taking place. But this is giving an advantage that the oxidation peak is coming, and that oxidation peak we are utilizing it for the detection of the. And if you try to see that the Bayer GCE and comparing to the Bayer GCE, the silver or the gold based materials are giving us a good amount, or I can say the enhanced, much enhanced the the current, so that can be utilized for the detection at the low level detection of these pollutants. Similarly, we can see for the for the sulfamethazine also behaving almost a similar way. That is no oxidation reduction peak. Okay. That is the irreversible type of the process. So pH dependence data, we try to collect it for the sulfamethoxazole or sulfamethazine using these the two the electrodes. With that, we can see that the region somewhere around 4 to 6, almost the neutral pH region. It's a very useful that almost the neutral pH region that is being given for the low level or the high current that we have obtained for the sulfamethoxazole or sulfamethazine. So it's an advantage. I'll say that this is an advantage that detecting these pollutants at the neutral pH. So you need not to maintain the pH. Sometimes what happens earlier we have tried to do with the arsenic. For arsenic we need to do at very low pH, somewhere around pH 1 or pH 2. So for that highly acidic condition we have to maintain, then we can detect that the arsenic. So in this case it is very useful. So electroanalytical performance of the silver and the gold based the materials for the differential pulse voltammetry that we have adopted, we have introduced here, and the wide range of the concentration of the pollutants, say sulfamethoxazole or sulfamethazine. Okay, this is the sulfamethoxazole. You can see the two different electrodes, that is the silver based or the gold based material. Okay, the electrodes we have introduced, and we can see that a good linearity has been obtained for both the electrodes. The LOD, limit of detection, that we have obtained for the detecting this sulfamethoxazole is 0.022 milligram per liter. That's a ppm level. And for the gold-based material electrode, it is 0.036 ppm level. And in case of the sulfamethazine, the LOD which we have obtained, it is 0.027, and for the gold base it is 0.035. We try to compare. You see that a very good linearity has been obtained. We try to compare our data with the literature value. We can see that a much lower, okay, the detection limit that we obtained with the help of these electrodes. Then we try to do this interference studies. For this, the sulfamethoxazole and sulfamethazine, it's a very high concentration that we have taken. And in that case, the copper is a little bit affecting the detection in both cases, sulfamethoxazole or sulfamethazine. The copper is hampering, I will say that, or interfering the detection of this. We try to collect the water sample from the different sources, the surface runoff. We have collected the water sample, and say this has been critically analyzed, the water sample, and we can see that the TOC value, IC value, and that is the inorganic carbon, which is 12.341, and the organic carbon was 4.6. It means that the carbon, either in the organic form or in the inorganic form, high concentration was there. And then the AS has been intended to use for the different elements. We can see that the magnesium was very high, and then the calcium was very high, and the little bit of zinc was there. And like that, the pH and other parameters that we try to see, nitrate was there, sulfate was there. So these are the parameters that we have analyzed. And what we have done, we have spiked with the sulfamethoxazole, and then we try to detect it using the spiked one, okay, the different concentration. And then what we have observed that these are the found values, and the recovery was somewhere around 93 to minimum 93 to the 103%, which is quite reasonable with the RSD values. Similarly, for the gold-based materials, it is 95 to 100% the recovery that we have obtained. This is for the sulfamethazine, the different the spring water that we have collected, and then again we have intended to use it for the for detection of the sulfamethazine. Here again, the recovery was a good recovery that we have obtained with the RSD values. So what I want to say that the stability of the electrode, we try to use the data I have not shown here, but we try to use the same electrode for the repeated operation, and 5-6 operations that we have done, and we found that there is no significant change. Okay, there is not at all a change we have obtained. So that we can say that the material which has been coated on the impregnated on the surface, that can be used for the for the repeated purpose and all that. So this is some more data. I think I will just skip this. This is for the cadmium and the lead detection that we have done it with that, and the simultaneous detection also that we try to. This is the individual, but the simultaneous also we try to detect these two elements. So that's lead and the cadmium, and a very good detection limit that we will be getting 0.79 or 0.88 ppb level that we obtained it, and interference studies and all that we have done. So with this, I would like to conclude that the novel clay-based nanocomposite materials were successfully we have synthesized it and characterized it, and then characterized. It's the characterization of the material and characterization of the the electrochemical behavior of these materials or the fabricated electrodes that we have done, and then we have seen that the specific surface area, electroactive surface area, or you can say that the RCT value, the charge transfer resistance, also is being decreased, or the area was significantly increased, and then we try to utilize it for the detection of the sulfamethoxazole or sulfamethazine. So this is this is one of my previous work, which in which we have developed a small device that is the the electrochemical sensor. I will say it's a very small device. These are the fine electrodes, the micro electrodes, which has been used. The technology was slightly different than what we have discussed here. And then this was, this is a small unit. You can take it at any place, and then you can detect the arsenic in the water sample. This is already commercialized. This the material. Sorry, this the device and all that. This the project we have done with the international collaboration with the Korean universities and all. So these are all. So thank you very much. This is a beautiful picture of the Mizoram. Those who are joining from outside. So thank you very much. Thank you.
Thank you, sir. So we will have a question and answer session. So those who have questions, you may ask.
Sure.
Any question from the participants? Okay, if I think there are no questions, so in that case, I would like to thank Professor Tiwari again for your wonderful talk, and thank you for sharing your research work and your results, and showing us that you are working in some very useful applications for the community as well. Thank you so much, sir.
Thank you, madam. Thank you once again.
Okay, thank you. I think we can go ahead with the next. We have informal invited talk from two. We already had formal invited talks from two speakers. We have one more speech from one of the patrons of this conference. So Professor R.K. Thapa. So, yes. Sir, before we start, I would like to give a brief introduction.
Right, okay.
Okay. Professor R.K. Thapa, he is a retired professor from Department of Physics, Mizoram University. He received his PhD degree from North Bengal University, Darjeeling, Then he joined Patsong University College in 1978. And after that, he joined Missouri University as a professor in 2007, where he worked till his retirement in 2017. During his 40 years of service, he was entrusted with several important responsibilities in the university, such as head of department, dean, School of Physical Sciences. He was the proctor of the university, executive council members, court member of the university, amongst many others, other responsibilities. Professor R.K. Thapa works on theoretical condensed matter physics, particularly in the field of photoemission, electronic band structure, optical, thermoelectrical, and magnetic properties of half metals and semiconductors. He has contributed more than 250 research publications in journals and also completed 9 research projects. He is a reviewer of 19 Scopus Index Journal. He successfully guided 21 PhD students. He also examined more than 50 PhD thesis work from various institutions. And during his service, he was actively involved in research collaborations with Indian institutions as well as couple of foreign institutions. And he was a visiting fellow of many institutions in national as well as international. Let me not mention every one of them, it's going to be quite long. And he has been awarded Best Teacher, Science Teacher by Mizoram Legislative Assembly. He was awarded an Eminent Physicist Award by Physics Academy of the Northeast India, Honorary Director, Chair Professor, and Emeritus Professor by Condensed Matter Physics Research Center, Nepal. And I am proud and honored to call him. He was my PhD supervisor and my colleague till his retirement day. So please, sir, you may proceed on with your speech.
Thank you very much, Dr. Kimi. It's nice to see you. Nice to meet you.
Yeah, nice to see you, sir.
Okay. I hope I'm not giving a stipulated time period.
I don't think so, sir.
Well, it will not be a scientific talk as informed by Dr. Divya. However, I'll try to, because whole day program you had, I didn't want to bother you. So I will not take much time. I'll be as far as short possible.
So sorry, sir. Sir, namaskar, sir.
Namaskar. Nice.
After long, we are able to see you, sir.
Really. It was a nice talk given by you. I have attended fully. I enjoyed it very much, Dr. Tiwari. Okay. First of all, the principal, the staff of Patsong University College, and Dr. Shetpuya, Dr. Divya, and other members of this organizing committee of this event. I really thank you all giving me this opportunity to share some of my, I don't know, Dr. Divya has not informed me anything about technical paper and all. So it will be just sharing my experiences. That's what you wanted to know about all this. So I'll be just sharing my experiences that I had with Patsong College as well as with my university, Mizoram University. I'll be as far as possible short. I'll be short as far as possible so that it will not be a bothersome to all of you who are there whole day busy with this prestigious event. Just to inform you that as already Dr. Laltaki Mizaring has informed that the chairperson, she has informed just I joined Patsong College in 1978. It was on 6th of December 1978 I started my teaching career after being a fresh postgraduate MSc in physics with specialization in solid state physics from God University. So I joined Patsong College, and from the date I joined Patsong College, I really had the zeal and always an enthusiasm and interest and ambition to have a research facilities there. That was in early 80s. So we could not talk anything about research there. So it was very nice that by change of Vice Chancellor at NEHU, Northeastern Hindu University, because we were under a Constituent College of NEHU. So a brilliant and hardworking Vice Chancellor came, Professor Dr. B.D. Sharma. He made all changes in the new appointments, including our Pachi University College, where we had almost full-fledged science departments. That was a great and unique opportunity for me because so many faculties, so many staff joined who had experience of doing research, especially in physics, science, and all, and the other science subjects also. So amongst them was Professor H.A. Lal, who is retired as professor of chemistry from Nehru recently. So he was a brilliant chemist and very much hardworking gentleman. So he started the research activities in Pachang College, and I got inspired by him. Then I joined his group. So I joined his group just to make some kind of conductivity measurements of some solutions that he was making in Pachang College chemistry department. And you all will be surprised to know that we worked so hard that whatever facility that was in physics department, I used it to measure the conductivity. And I believe that the physics department, like Dr. Gurum, Dr. Dibet, Dr. Shepte, and all, you'll still have that instrument. It's a multimeter, but very high quality multimeter. I use that one, the huge one, black one. It is still there, I think. So with the help of my assistant, physics lab assistant Tuama, I hope he's still there, but he has retired, I know. So I could make measurements of conductivity of the samples, the chemicals that was developed there by Professor Lal. And we were so lucky to have our quick publications. So that was great inspiration to me. So I started my research activities there itself with the ambitions always that I should establish a center here, or a group, so that with all facilities, so that my students who pass out MSc will not have out of place, that they will not be able to research. And it truly happened that I got quickly so many research projects from various funding agencies of India, like DAE, CSIR, UGC, DST, and so on and so forth. And I was having computers, so I could have my students joining my group, joining me there to form a research group. And amongst them was first Zaitan Java Pacho, who is a professor of physics in physics department, Mizoram University. He was the first one who came with the intention of doing some works with me. When I asked him from what was your MSc specializations, he just said that, sir, it's nuclear physics. Then I said, how could that be? I do in computational physics by doing computer programmings, by using Fortran. Will you be able to do? Then he said, yes, sir, I'll try my level best. And he did level best, and he completed also. So he's a living example. He's still there in physics department, and he was a former dean and former head of physics department also. And with him followed Dr. B. Zoliano, who is a professor of physics in Jeevteri College, is still there, and others, including Dr. Lal Takimizading, who is now the chairperson of this session. I feel so proud to have all these students, including Dr. Das from Kolasip College. He's the head of physics department. Dr. Gurung, who is the head of physics department, Pachang University College. Then they were followed by others, which was mentioned by Dr. Laltakimi just now when once he gave my introduction, that 21 PhDs were produced. So amongst them, I think 5 of them were the early part. The later ones who came were all from Mizoram universities. When I was there, when I joined the faculty of physics department, Mizoram University. So I feel proud to mention here that nowhere where we may be, if facilities are not there, we should try to create the facilities, and you can always work hard and you'll bring fruitful results. So after that, I joined Mizoram University as head of department first. Then later on, I became dean, as mentioned by Dr. Lal Takimi. Then I was proctor also. Then I worked very hard to have this department established. And now we have so many PhD students, so many students who have got their doctorate degrees in various colleges of Mizoram, also outside Mizoram, also abroad. So this is the brief introductions I want to give about myself. So what I want to hint my younger generations, colleagues, the students, is that nowhere, wherever you may be, please work hard, create the facilities for your research work. I still remember where I'm in Poland as a visiting scientist of INSA in 2016. My colleague who has invited me, she did not have all the facilities, all the space, rooms that she wanted. She had just almost hardly 10 by 10 square feet of room. And there she had established one international level of laboratory where people used to come from every part of Europe to do research and all. So it does not mean that you just require space only. The main thing is that you have to work hard, create the facilities of your own. Definitely, it will be always successful. You can guide your students. I feel proud and honored to be a member of this event as a patron as well as organizing committee. I thank the principal, the faculty of all the faculty of Pachi University College, as well as the faculty of physics, especially of Pachi University College, for honoring me by as a patron and as a member of the organizing committee. I thank you very much for remembering me. Although yesterday I could not be there, as I informed Dr. Dibya that we had a very bad power situations, so there could not be network and all almost the whole day. So I missed yesterday's the opening ceremony and all. I apologize for this from the committee. Once again, with these few words, I thank once again the organizing committee, especially Dr. Shetpui and Dr. Dibya, principal and faculty of Pachi University College, for remembering me. Thank you so much. Thank you, Dr. Kimi.
Thank you so much, sir. Thank you for your sharing your experience and for your encouraging words. Okay, once again, I would like to thank the speakers of this session, Professor James, Professor Tiwari, and Professor Thapa. I think I'll hand over the chair to the conveners.
Thank you, Dr. Chakimizadeh. Hi, sir. This is me, Shriyazwala. We are so happy to see you, sir. Actually, we still have some of your equipments. I think it's a kind of some museum items right now. There are some like your conductivity apparatus and all those things. They are still here. So you have been really an inspiration for all of us. In spite of all the inconveniences and all the circumstances you were in, you have started your research, and I think your hard work is really appreciated by the department also, and also definitely by the Mizoram University Physics Department. So we are following your footsteps, sir. Yeah, we are so happy that you could give a speech at this hour. Friends, our evening program, our session 3, technical session 3, invited lecture session 3 is now over. Today we have another special talk at 6:30 by Professor Roberts I. Eklitis from Latvia Academy of Sciences. So we are hoping that the same Zoom link can be used for that talk. So if anyone is interested, you are all invited to hear Professor Roberts Eklitis lecture at 6:30 p.m. today in Indian Standard Time. So unless my colleague DP Rai, Dr. DP Rai has anything to comment, I think we can close this session. Divya, you have anything to comment or?
Hello. Good evening, sir. It's nice to see you that you manage the time for us. And yesterday I was giving a call to you so many times, but maybe because of the heavy rain, there was a power cut down and the network failed. Yes. And, today I could see you, and I'm very happy that you. Because I was a bit worried that I was not able to reach you yesterday. So thank you, sir. Like you have attended and you have given a very nice motivational talk to us. And as Sir Sheta has already said that we are in your footsteps and we are trying to establish a good research lab here. So that's why we have the motive of this organizing this conference is also the same, that we want to highlight our research and our research and our institute as well, so that people know about we know that PUC is very famous in within the states, but outside the states we have to make highlight, and that the university or the institute can be highlighted only from the research. If we do research, if we publish the papers, the people from all over the world, they will read our work and they will understand and they will come to know about our institute. So that's the main, the motive of organizing this conference. That's why we are inviting speakers from different part of the country, and even from India also. We try to fetch the speakers from west to east and from north to south, so that it will cover all parts of India. So, and another thing is that you are here. That's a great motivation for us, and it's nice to see you that healthy and you are doing. Still, I can see some of your papers publishing with the group of Amit and group of Gimire, and even with me also you are publishing, you are giving the results, checking the papers, and giving your ideas. That's very nice, sir. We pray for your good health and keep on guiding us. Thank you very much, sir.
Thank you so much. Thank you.
Okay, I believe that concludes our session. Thank you, everyone. See you again for Professor Robat's lecture at 6:30 p.m.